right, welcome everybody. Tonight is the 21st of September in Dallas and the 22nd in parts of the world ahead of Dallas. So this is the Dallas Personal Robotics Group Robot Builders Night Virtual. We'll just do the usual and go around the table, talk about our projects we've been working on, ask questions, try and stump the club. My name's Carl Ott, current president for a little bit longer, and I'll be the facilitator, but I don't have any other news. Before we just jump right in, does anyone have any news worthy of sharing with everybody before we jump in? Probably not. Okay. Well, then with that, let's go ahead, Ted. Let's take it away. What you been doing?
All right. So I've been working on this Strider walker robot. And anyway, I had to get my 3D printer printing fairly reliably and with a lot of accuracy to get all these little legs to print. And even then, in order to get everything to turn smoothly, I had to sand it down so there weren't any like square edges that would catch. And anyway, so I've got hooked up. It's not done yet, but I've got a little battery pack. So you can see all the little legs going. And yeah, it took a lot of post-processing, hours of sanding and drilling holes and making sure the screws didn't stick out. I have a little video to show. Let's see. Yeah, we'll do this one. And there we go. So let's see. Where is it? There it is. Okay. And they just have it walking across the, whoops. Did I lose you guys?
We're still here. Looks good.
Well, now we did.
My screen turned off. Huh. That's weird. Okay.
We're watching Rory play accordion.
Oh, that's my son. Let me stop that one. And I guess we can go. Can I go back? Yeah. Let's see. So there is walking again. And yeah, it can go over short obstacles like onto a carpet or something. Anyway, that's what I have. And it's a pretty cool little model. It's a lot of work to print it out, but it was kind of fun. Let's see, stop presenting. And yeah, any questions?
What are you going to do with it?
I haven't decided yet. It was just kind of a test to see if I could make a walking robot. And I was thinking possibly an outdoor autonomous robot, but then I started looking at all the little legs and how something could get stuck between the legs and clog up the works. And I started thinking that scaling it up probably wasn't the best idea.
I think you should take a whole bunch of them and see how big an object you can move.
Yeah.
Ted, can you turn or steer with that?
Yes, it has differential steering. You just put one set in reverse and one set forward, or one set faster than the other, and it'll turn. So there are two motors down there. They're the little N20s, and you can control them separately. Right now, I just have them directly wired to a battery pack because I didn't get as far as putting in a speed controller.
What about like weight? How much? It looks like it'd be like you wouldn't be able to get much weight above center mass up very high before it starts to really tip over.
Yeah, it would tend to get a bit tippy. I've tried putting weights on, and it doesn't seem to mind carrying a lot of weight. But You're right, the center of gravity, if you got it up very high, would get it tippy. But it is stable. It's surprisingly stable. I think I don't know if you can see that, but these legs spread out a ways, and there's always one forward and one back somewhere on this set of 3.
Well, it might be interesting to see 2 or 3 of them in parallel. That would be very stable.
Yeah, I was thinking, put one set behind, one in the back and one in the front.
So is the stride divided up into thirds because you have 3 sections of feet?
Yeah, there's 3 sections on each side, 3 sets of legs, and each leg has 2, or each well, there's 3 pairs, I guess, and there's a front and a back. So this is if you've ever seen those strand beast walkers, this is a form of that. It's a little different leg mechanism, but similar.
Yeah.
Pretty cool. I could see doing some steampunk something with that.
Yeah.
That's neat. So you're going to do more work on more of that next week?
Yeah, I might just try to get it some speed controllers on there, and probably put a radio receiver on next, and remote control it.
That's too bad that the parts require so much sanding. There's no way to get the surfaces, the mating surfaces, smoother.
Well, if I didn't design this, if I had designed it, I might have made the tolerances a little bigger. Whoever designed it made the tolerances really tight. It looks like it was a Japanese guy, and they're pretty good at these detailed things, I think. And so, yeah, he just designed it with really tight tolerances. And so, once you start trying to use screws for the joints and stuff, the screws will start to back out, and then they'll start hitting things. And so, yeah, there's just a lot you'd need to do to make it easier to build.
Otherwise, it leaves a trail of parts behind it, you're saying?
Yeah. Well, what I found is the first time I put it together, I turned the motors on and nothing moved.
Ooh.
I think the legs moved like a quarter of a turn and then just stopped.
A little too much interference somewhere.
Yeah.
That'll catch up with you.
Yep.
That's pretty cool. All right. Good deal. All right. Well, surely with some 16 of us online, somebody has something going on in the last weeks. So beyond just Ted. Is that Doug waving? Is it Chris Murray?
Okay. Mine is quick because I haven't actually done much in the last couple of weeks. I'm starting to find a little more time again. But yeah, so here's my Romy. And, a couple of weeks ago, I said, going to try maybe something real simple, subsumption style control and keeping it deliberately as simple as possible. Now, I wanted to get the LiDAR data, in there into my Python-based logic. And that's where I kind of got a little stuck and been spinning my wheels a little bit, because it turns out, unfortunately, the libraries I was able to find that support, getting the LiDAR data into Python, that just didn't seem very reliable. It just, stopped giving data after some time. And so, and I didn't see that problem, if I used any of the sample programs that are written in C++ that come with the LiDAR with the SDK. So I don't know why that is. I didn't really try to debug it. Maybe it's because I have a newer version of the LiDAR and those libraries are written for older versions. But anyways, I kind of got stuck with that because I really want to use the LiDAR, in addition to my 2 ultrasonic and 2 IR sensors, just so I have, just do something simple, like divide up the 360 samples that I get right, divided up into 12 bins, right? So I have 12 virtual, IR sensor readings that the LiDAR would give me. So that's the idea. Getting stuck with actually getting the data in, and then sort of got off on a tangent a little bit in how to accomplish that, and was going down a path of figuring out, okay, if the code that they provide with the LiDAR works and it's in C++ and whatnot, but why not just use that and somehow send the data over to my Python program, through some PBD, inter-process communication, and there's numerous options available on the Raspberry Pi or any Linux platform. And so I was exploring my options there. Again, kind of just, going off on a tangent there, really trying to get that done, the basic function really of getting the data in. And so I was looking at different options, and it's all interesting, and explored things like zero message queue, which is, certainly a technology worth, knowing about. But then I realized, wait a minute, I was kind of heading down a path almost, again, making things complicated. Not that I wanted to, but I realized, it's starting to feel a bit like, well, I've got this program here sending data to this program there. Starts to look a lot like RAS, right? So I wanted to to avoid that, right? I wanted to deliberately keep it simple. It just didn't let me keep it simple, and so now I made a little bit of 90-degree turn, and I'm fiddling with RAS again. So I'm not terribly focused lately on my approach. It's just, I was really hoping to keep it simple. Just read the damn LiDAR, scan, in my Python program, and that just wasn't reliable. So, so I'm now a little bit back and forth again. Hey, should I just do this in RAS? Maybe take advantage of some of the plumbing and the driver that they have for RAS for the LiDAR, but keep just the logic really simple, right? I mean, maybe just take advantage of some of the, the good things in RAS, like the existing driver for the LiDAR, like the visualization of the LiDAR data. Those are the things I really like. But then not really get caught up in trying to do the full slam and all the complexity that comes with that, right? So maybe there's a middle ground. I'm thinking of taking advantage of RAS, but still keeping it overall fairly simple. So that's where I'm at right now. Again, a bit unfocused, and haven't really spent a lot of time on it, but hopefully that'll change now that my sunroom project is wrapping up. Now I should have some more time again. That's all.
Well, that's cool. Simple versus complexity, right? That pendulum that just kills you every time.
Yep.
All right. So who has something else next in line? Oh, we got. So I didn't see who was first. Murray, you want to go first?
Okay, all right. I have been still working on my operating system, and kind of getting to the point where things are relatively working. I don't have a demo, but I just spent over $300 in shipping for 2 small FedEx boxes from the US. This is from Servo City, and the minimum charge from any courier or postal service vendor from Servo City to New Zealand is $125 US. So even if I buy one $5 part, it's $125 to ship it here. So I've emailed them and I have nothing back, but I do have a report on what I have built for $1,000. 300 of it is shipping, and that is, I now have the beginnings of a Mars rover. And so that's the front sensor frame for that will mat. That's where I'm going to put the piece of polycarbonate. And but this is $1,000 worth of parts. It's a bit much, but it and I haven't had a chance to plug it in. Of course, I just got it actually day before yesterday. But this is 2 shipments in small boxes. and I'll probably need 2 more shipments, and then I'll have enough to actually build most of the rover. But there's lots of work to be done. I've just kind of started on that. I'm still focused on trying to get the KR01, my main robot, running. And the only other part that I can report is that I'm now plugging 2 UARTs. Is that right? No, sorry. 1 UART. I've got an itsy bitsy RP2040 now plugged into the Pi on the half a UART. The Pi uses one of the UARTs for the USB, and the other one, I think, for the USB, and then the other one's sort of a half the UART, and that's the one that's plugged into the itsy bitsy, and that has all of the front sensor array stuff plugged into it so far. But I'm not remotely happy with the performance of the UART. It's not that reliable. I mean, I think you just have to get used to the fact that it doesn't always send. I'm only sending 4-character messages, and every once in a while it gets out of alignment and starts sending stuff wrong, and it's just it's weird. I wouldn't expect that to be the case, but it's not reliable. And so I'm at this point looking into buying an STM32. I was going to possibly get one of the ST boards, but they're pretty big. And they do have a nano board, but it's only 16 megahertz, whereas SparkFun sells a little board, a series of boards called their Micromod. I don't know if anybody's used these, but they're basically, the CPU is on a small modular M2 connector, and they have ESP32, ESP32, STM32, RP2040, and a couple others that you can buy the CPU as a little board. And then the carrier boards, they've got like 5 or 6 carrier boards. So one of them is feather sized, so you can plug a STM32 onto a feather sized carrier board, and that's a full STM32 on a board with enough pins for me. And the MicroPython implementation of an I2C slave works on that. So I might go ahead and buy that. It's about $30 or $40 tops, and see if I can get that working, because I really want to have like 2 or 3 of these. And if I have to use a UART on a Pi, there's only one. So even then, it wouldn't really work that well. For this Mars rover project, I kind of would like to have 3 sub-processors. So I'd like to have a small microcontroller for each pair of wheels, if possible. And then let each of the microcontrollers take on the responsibilities of the encoders and the motor control and all of that. But if that's not possible, I'll just have a Pi running everything. But I'd kind of rather not do that. But that's about it in terms of progress. Been fairly busy. Still have a flooded basement. I'm on plumber number 4 now, by the way. I'm supposed to get a phone call from him today. If he doesn't call me today, I have to look for plumber number 5. Apparently, plumbers are sort of like glass slipper recipients. You have to be really nice to them here.
Hey, Murray, you mentioned that you were sending a packet with 4 characters in it.
Yep.
Okay. And you said you were losing sync. Usually, when you do those things, you send out a header bit, and that's what you sync up. Otherwise, as you're reading, if you don't see the header bit, then you don't.
You flush.
You flush, you know. And then when you see the header bit, then you start. And it's not it's a good practice, and it's not always done. But to put a little checksum on the end of it, it can be something simple like the sum of the upper bits,
Right.
And that way you'll get rid of all of those sync problems.
Well, what I'm doing is the Pi serial library, which I now have to use the async Pi serial library, which is even more tricky. All these Pi serial libraries have a read line method, and so you read until a new line. So I'm actually kind of not being quite accurate. It's a 4-character message, but it has a new line. So I read to new line every time. So it kind of gets around that checksum kind of issue.
Well, yeah. What I'm just saying is a header bit will keep you synced.
Okay, I'll look into that. I don't remember if that's even in the Pi serial library.
Well, it's you. You create your own.
No,
I see.
I mean, I think he means a byte. You just send a special byte.
Okay.
Or 2 bytes if you're really paranoid.
Okay.
So maybe when you see a combo of 255 and 254 or something like that,
Right.
then you know that you've you've started a packet. Or
Well,
just-
what I'm doing is I'm running it at like 115,000 and 115 200 baud or whatever. It's a pretty high baud rate, and it didn't seem to matter. In fact, it works better at a high baud rate. And what I'm doing is just throwing out messages that are garbled, basically. And since the whole loop that's running is running at, I got it at 50 hertz. I had it at 20 hertz, but I think I bumped it up to 50 hertz so that it would be faster than the robot. And because the robot's running at 20 hertz. And so I figured that if I had the loop for this, which could easily do faster than 50 hertz, but I've got it at 50 hertz. And so it's sending lots and lots of messages, and I throw out, I don't know, every 10th one or something like that. So it's not really a problem. It's just that if I really wanted to start using this as I'm not sure if they say this in the US, I don't remember this. In New Zealand, they say use it in anger. Has anybody heard that before? It's a New Zealand term. If you use it in anger, you're using it like seriously. So I almost said that. And our backyard here is called a back garden. It's not a vegetable garden. That's a veggie garden. Our back garden here is the whole back of my house. So there's all this terminology, and I keep getting mixed up. I've been here too long. In any case, I was going to start using it in anger. And I don't think I'm ready to start using the UART in anger, although I'm angry at it. I think that if I can get the STM32 board to work as an I2C slave, I would kind of prefer having a slower but more reliable and more detailed API where I could actually send like Python objects, which would be really nice. Like I could actually send an object rather than just a little 4-character string. So that's kind of the goal. If I can get a library, even if I have to write the C library myself, if I can get it so I can pass objects back and forth across an API rather than a UART, I would much prefer that. So I'm still kind of thinking about doing that. The UART's working, but I'm not happy with it.
So one other suggestion, I mean, I'm doing a lot of things with UART, as I've mentioned, but not so much actual UART, like it's USB virtual serial port in my case, usually. And I'm pulling the data in, in Python. And so you mentioned the read line function that comes with the Python serial library. So I found that I have better success if I don't use that and kind of do it more at a low level. And I'll have to dig up and put it in chat what I'm doing. But basically, one thing I found with read line, right, because it's waiting for the new line character, and it's doing a bunch of things behind the scenes. So number one, I've seen it to be actually rather inefficient, right? I've noticed for just the simple task of pulling in serial data at that I'm producing at a rate of 100 hertz, okay, so a little faster than you, but again, it's just like 30 bytes at a time at 100 hertz. Something of that order of magnitude. I mean, it's really nothing, okay? And I'm pulling that in on the Raspberry Pi, and it's almost using up the whole core of the 4-core thing, running it, So there's some inefficiencies there that are just really bad that I just can't live with, okay? And so I found myself using some of the other APIs that come with the Python serial library, where you'll do things like there's a way to check, okay, well, how many bytes have you received lately? Okay, there are 5 in waiting. All right, let me read those in. And then you just kind of parse them. You read as many bytes as you think you're expecting to get, for example. If you didn't get all of them yet, well, do another read, okay? And then you kind of look for the new line character manually, right? You don't ask the library to do that parsing for you. You just kind of do a little bit of that legwork yourself. And, I just found it to be an order of magnitude more efficient. So there's something weird going on with that readline function. And I've seen people on the internet also point that out. So I don't think I would be the only one saying that. So give that a thought. But the other thing I was thinking about, and I'm not sure how that actually would be done in the Python serial library, but let's say you do have a problem with electrical noise, and I don't think you can say that you know what the problem is, right? You're not really sure, I think, why you're losing data, right? You're suspecting last time you said you're suspecting maybe some electrical noise, right?
Not so much now. I used to have on the KRO1, I've got two microcontrollers, one in the back of the robot right next to the Pi, and the other
Okay.
one at the front of the robot. And I've swapped them now so that the actual the serial line is actually running back to back rather than all the sensor data.
Okay, so it's probably not
sensors
electrical
next to
noise.
it,
I was just going to suggest that, and then again, I wouldn't know how to do that necessarily, but on a regular microcontroller, right, we've had to do it often where you check the necessary flags, right? Hey, has there been a framing error? Has there been an overrun on the receiver? Have I missed a byte or anything of that sort, right? You can usually check for these errors, and that tells you, okay, I just received some garbage, right? And so no surprise, my data is not making sense, right? So I don't know if you can actually do that in Python in that library.
yeah.
But if you're not suspecting electrical noise, then never mind that suggestion. That's not really useful.
I think it's more like it. I don't know that. I mean, you're right. I can't tell that it's not electrical noise. I don't suspect that actually. I don't know exactly why it gets out of sync, and it's not a huge problem now that I've kind of, because there's a lot of different things going on. First of all, I'm running the UART data on an IRQ and an interrupt on the microcontroller. So the Itsy Bitsy's actually got a separate interrupt for each one of those inputs. So it's actually running on an input, on an interrupt rather than a pole. And then it sends across the UART data to the Pi, and Pi serial has an interrupt as well. So I can run that on an interrupt. So I've got callbacks for all those, 5 callbacks. Yeah, 5 callbacks. And then I have to run that on Python's async IO. So there's an async IO sublibrary of Pi serial for async IO, and that allows me to basically not have blocking loops and things like that. It's basically you do an await on the message, and it just sits there and waits for it. And then when the interrupt fires on the microcontroller, it fires across. The interrupt on the Pi fires. It's actually pretty good because then you don't have anything polling. It's just sitting there waiting for interrupt at both ends. But that's possibly why I'm getting these problems. It could be that they're getting out of sync somehow. I don't know.
When you say you get out of sync, you're missing data, or is that what's happening?
Well, I'm expecting my packets to be always five characters, four ASCII characters plus a new line, and if I spit out through an exception what it actually gets, and I'm getting like 3 characters sometimes, or I get 2 characters. So it seems to drop a byte basically now and then. But like I said, I'm just throwing that into, I'm popping it up on the screen in the console right now so I can see that those errors happen. But over the last few days, I've kind of got it to the point where it's pretty reliable. I'm not happy with it, but it's fine. I mean, I don't want to make a big deal of it because I'm probably going to stick with it for now until I try out the I2C slave thing. It's good enough, actually. If I wave my hand in front of the robot and I can see on the actual infrareds that, they have a little red LED, I can see it pop up, and then I can see a little, I've got an RGB LED on the Itsy Bitsy, and I have it colorized based on which of the 6 sensors actually. So I can see the color flash on the Itsy Bitsy, and then I can see on the Raspberry Pi console the message come across, and that's not bad. Like I said, it drops bits now and then, but if the robot's running around and it runs up on something, that message gets through in time. It might take an extra 20 milliseconds or something like that, but it's reliable enough. I just think there shouldn't be any errors at all. I can't understand why there's even one error. But in terms of functionality and being maybe a little more pragmatic about it, I've spent way too much time on it already, and it does function. It's just not satisfying. Anyway, yeah.
Hey, Marie, I have another question about New Zealand, and it relates to this headline that I saw. And I'm just trying to figure out what's up with that. Men caught smuggling KFC? What? Okay,
Auckland is, there's a term in New Zealand called a Jaffa, which is just another F Aucklander. And F stands for a word I can't say online. And so Jaffas are the wealthy Aucklanders who act like complete jerks. And they're a well-known phenomenon. Like if you live in San Francisco, you know that lots of people in LA are nice people, but there's the LA people who are complete jerks. And Aucklanders are often like that as well. So here's Auckland all in level 4. They can't even get out of their house. And the rest of the country, because we don't have any COVID people down here as far as we know, the rest of the country is now in level 2. So Aucklanders have been making a point of trying to escape Auckland. It's like, one of those movies, Escape from New York. It's Escape from Auckland. And they've been driving across farm paddocks. They've forged documents to try to get by the police. There's this wealthy couple who got outed for flying. One's the son of a court judge, and he plays pony polo. These are really wealthy people. And they managed to lie to a police officer and use some kind of exemption to get past a police cordon, drove to Hamilton, got on a plane, flew down to Wanaka, where her father's has a house in Wanaka, which is a resort area where all the houses are like $4 million. And they were going to hang out. But people in Wanaka said, hold on a second, these are Aucklanders. And they called the police on them. So it's sort of like this. It's just like, it's like a Kurt Russell movie, just except they're all Aucklanders.
Okay.
Yeah, I saw that and I said, I can't wait for the night so I can ask Murray what's the going rate for contraband KFC.
They're not allowed. Okay, they're not allowed in level 4. You're not allowed to get takeaway. You can't. At level 3, you can, but in level 4, you can't go and get takeaway. So somebody tried to smuggle takeaway into level 4 Auckland.
You guys are hardcore, man, down there in New Zealand. There ain't no way.
We don't have a lot of COVID down here. That's why we're hardcore about it. I can walk out on the street there and not really worry too much because we're hardcore. They shoot people awesome. Here. No, they don't shoot anybody here. Sorry. That's in Texas, right?
Oh, yeah.
Thank you, Murray. That made my day. Appreciate that.
We need someone with an eye patch, right?
Arr.
I like Kurt Russell. He's pretty cool.
You did have a shooting incident, though. It was in the news a little while ago, right?
Yeah,
and you heard about our cricket team?
Yeah.
They pulled our cricket team out of Pakistan. There was a terrorist threat or something. They pulled them out in the last minute. They were going to, I think they were on their, I can't remember the details. I don't watch cricket, but apparently cricket team was either there or on their way there. And they turned around and came back to New Zealand because there was some threat of them being killed, I think. Yeah, we get a few things happening here, but not much. Mostly just gang activity. We got a lot of gang activity here. Because we aren't hardcore on them for some reason.
Didn't we just miss Talk Like a Pirate Day? Wasn't that a thing we just missed? Didn't it just happen a couple
I
days?
didn't miss it.
If we missed it, we'll have to bring it back. Maybe that could be the Robot Club theme next year, the pirate contest. So.
All their gangs are fast food smugglers.
Yeah. I'm trying to find this book I have. There's actually a really good book about New Zealand gangs. It's kind of fascinating. I mean, Hell's Angels in the US and stuff like that, but here we've got like the Comancheros and all these American named gangs, which are mostly Maori, and they drive around on big fat motorcycles and make a huge amount of noise, and they have these massive drug busts where they like $44 million worth of cocaine, and it just happens over, and the cops here are totally over, catching these guys. But there must be just an enormous amount of drugs coming into New Zealand every day because there's a drug bust like every month. It's just amazing.
So most of the gangs.
One of the gangs bought a PR company's support, so they've got a PR person to promote the gang now.
Image is everything.
They're a community organization now.
All right, well, that's pretty cool.
Anyway.
So it's great to have that perspective. And well, if we swing back around to this time zone, so Doug, I think you're next in line. Do you have the KFC smuggling robots yet?
No. A couple of things. One thing, there was a gentleman here that was making some complex 3D printed, I think it was a dog robot. I don't see him on tonight, but anyway, I asked him why were the ultrasonics pointed, in like that, because it just didn't occur to me. Well, I started looking at it, and it makes a lot of sense. I'm going to show this up here on the screen. I hope it'll show. Maybe. Okay. So originally, if you recall, I had this little piece on the front of my robot that was tilted back 15 degrees. Well, I got a big sheet of paper and mapped it out, and sure enough, this is what it got. So now, I just pulled out Inkscape and made some 15-degree arcs and segmented my three together. So here's what you get if you have 0. And here's when you have them tilted together, they cross. But if you do 15, they overlap quite a bit. And you go a little more, they underlap. And eventually, if you keep going, you'll end up with them diverging pretty quick. So what I decided to do is I was trying for 17 here, but I ended up, look from the paper, it looks like I got about 15. And that's because these assume a 15-degree arc, and probably those sensors might be 14 degrees or whatever, or my mounting might not be good. So instead of this, where they were pointed with tilted to the back, I've now gone to where they're tilted to the front, and I now have a pretty wide vision in front of me with distinct left and right, and a little bit of overlap. So I'm real pleased with that change. So that was one change I made.
Doug, what sensor are those? Which sensors are those again?
Those are those Pololo 4071s. I love them. I absolutely love them.
Are they IR or?
They're IR. Actually, I think they're time of flight sensors.
Yeah, Carl, they're the replacement that Pololu puts out for what used to be all their sharp sensors. So like I've been using the sharp ones, the 150 centimeter ones, and there's this whole new line at Pololu of these small ones. They have the same footprint. This PC board's the same size, but they're a whole different line now.
Oh yeah, really, really nice. They have a little light. They have a LED on the back so that you can just turn on, power it up, and you can see if the sensor is working. It's really nice. So that was one thing.
Doug, I have a question.
Yes.
With the sensors crossed over like that, does that mean that you have to know the distance of the detect to know if it's on the left or the right?
That
is, the right sensor will have a left detect and a right detect at different distances.
Well, most of the time, up to a certain distance, you're probably not going to get, I don't know if I can show this, to a certain distance, right about up to here, you're going to be getting probably all three. Okay. So all three will light up. It's past this, I'm going to call it the diamond shape. I don't know if you can actually see the diamond. And they start spreading out. And there you get a very distinct left, right, and center. But the right, left, and center are obvious. The left sensor is giving you the right signal, and the right sensor is giving you the left signal. And then the center sensor is going in the middle. And as you go out further and further, eventually they'll spread to the point where you won't have any overlap. But that's
what's the advantage?
Pretty far out there.
What's the advantage of crossing them then?
Okay. Like I say, you have to take a look. Okay. I wish I could have this better. If you see this guy, oh, wait a minute. I could probably pull it up on. Oh.
Yeah,
if you see this, this one is spread. There's big holes in between them, but you got to definitely left and right.
Okay, well then change the angle and close the gaps. I don't get it.
If you do that to 0, you can get this. Okay. But the angle that you have your holes from what's in front of you is pretty big down here. By crossing them, there's that you really get to the tip of that diamond before you have to worry about holes. And realistically, they're not. You're not going to.
You're closing the near holes in your coverage.
You're closing the near hole, and you're spreading out. There is a period in the diamond where you have sort of where they all three converge and cross. It's going to be like a minimum of what you can see in front of you. Okay, and you can move that diamond's position by changing the angle. Okay.
How far
Once
away
you,
is that on your current setup?
give me a second.
Yeah, so it seems to me like you're just moving
About
the
24
whole-
inches. Oh, you mean not the diamond, but the diamond is probably around 7 or 8 inches.
And by the way,
But-
the name of the guy you're thinking of who brought this up is Glenn Mossy.
Okay, Glenn. Yeah. Anyway, so I mean, I thought about it. You know, I was wondering why they did that, and now at least I think I know why they do it. And it's real easy to simulate on a program like Inkscape. You just take 15 degree, whatever the sensor angle is. You just take an arc, and then you just put them next to each other and change the angles of your out ones and see where they go. So it's actually pretty. It was just I hadn't thought about it, and I thought there might be something that would be worth sharing with something.
So
And then,
Doug, what limits how close you can put the sensors together? Is it the sensor of the black body or the green PCB?
okay, right now the way I have them set up,
Because to John's point, like, so wherever you have that diamond, in a way, you've got an artificially constricted narrow field of view versus if you could get the sensors butt against each other, then you could line the edges of the cone and you could have a wider field of view. And
that's a good point. We might try it, but I'm saying right now I've got them from the center of sensor to the next center of sensor is about 4 centimeters.
but are those green cards your design or they came with the sensor?
This?
Yeah.
This
So
is-
you got
that's just mine. I made that on a 3D printer.
the green, but the green body seems to make the space minimum between the sensors, right?
Well,
They're
Carl,
about, like I say, from center to sensor is about 4 centimeters.
and
Okay.
Carl, they
Here's what-
replaced these sensors, and they use the same sized carrier board as these. These are the old Sharps, and those ones are the new ones that replace
Yeah.
these.
The actual sensor itself is 6 millimeters, 6 millimeters big.
Yep.
Okay. So
Okay.
it's kind of cool. And so that was one thing that I did. And I had some other things. As you can see here, I've got an IMU sitting on the top of this guy. And I was saying, well, you know, if I like to make a lot of little robots, and I really wouldn't want, I was wondering if I saw a new part from, actually I saw it on DF Robot, and it was called the WT661. And it's a little module like this. It cost about $25. And they have one that's called the WT901 or something like that, but it's actually a 9-degree of freedom. Otherwise, it has a magnetometer in it, and I think it sells for about $30. So I bought this one because I was just trying to get the cheapest one to see if it was any good at all. Okay, and I'm evaluating it now as just something to put on a cheap robot. I'm going to share here, I think. Okay. But here's their little, and I'm just wiggling. If you look at my picture, you can see I'm just wiggling it all around, and it's doing all sorts of crazy stuff. Some cool things about it. They have the accelerometer, you can see, and the angular. I think I might have did, no. Okay, so here you can see the angular velocity, or you can see the angle. Now, come on, seems like it takes takes a while for it to get going. Or I might have crashed it. Yeah, I might have crashed it. Anyway, there's a couple of things I wanted to show about this. This is still working. Let's see if I can get it going. No, that's not working. It was working. Is in their configuration. They have now obviously you can do this programmatically. You can reset the 0 if you want to. This particular one is serial. There is an I2C option, but there's a disadvantage for the I2C option because this is using a fairly standard sensor. It's using an MPU 6050, which you can buy on eBay for $2 or less. But what the secret sauce is, they've added a microprocessor and they're doing a Kalman filter on it. So that's why you got an angle, why you have the angles. And they also have a couple of things here. They have what they call a static threshold, and it's defaulted to 0.122 degrees. But what that means is that if this thing does not change by 0.122 degrees per second, then it essentially ignores it. So if I just set this guy on the table and didn't touch it, it'll always read whatever angle it was. It'll never change. They also have, let's see, is there anything else? You have to let it, so if you put it on your robot, what you have to do is when it turns on, it sits for 3 seconds and does an acceleration calibration, and then you can start polling the serial port. Now, why I said that the I2C has a disadvantage is because the I2C, if you're using that interface, is actually pulling it straight off of the MPU 6050. So you're not getting any, you can't get the angle information on the I2C interface. Now, the other thing that's cool though, and I haven't dug into it yet, but it seems like you can also integrate GPS into this calculation, because the 6050 is supposed to be able to handle that. And their software tool, the one that I'm showing you right here, actually, if you look at the 9.10 version, actually has spaces for the GPS. Now, some gotchas. If you're interested in getting one of these, I'd probably go with the 9 degree. If I were doing it again, I'd probably go with the 9 degree of freedom. But you also want to make sure that it comes in lots and lots of flavors. Otherwise, the one that I'm using, which is probably the most robotic friendly one, is the TTL version. That also comes in RS-232, but it's a true RS-232 port. You're not going to find that anywhere. It'll be hard to use. And they also come in CAN bus. Like I said, they come in I2C. They come in several other combinations of buses. So anyway, I thought this is something, like I say, I'm evaluating it right now. Might find it on a replacement for a BNO 055 because it's got a nice little package. I could put the other one in a 3D package, but this one's kind of, and it's a little cheaper. I guess it's not anymore because there's the Grove version of the Adafruit BNO 055 is now $20, so probably not cheaper. But anyway, I picked it up. I'm going to play with it, see what's going there. Okay, now one other thing I wanted to show. This popped up on Instructables, okay? And it's was actually sponsored by DF Robot. And there's a couple of things here. Obviously, there's a spinning LiDAR on the top. He's got a webcam over here. I'm not going to go into all of that, but here's what the parts are. You can see he's got webcam. He's got a nano. That's for being not as a main controller. That's simply to provide tilt information. And this is the WT61, but it's the DF robot version of it. This is a nice little OLED. So that was kind of cute. You know, these cost about $2 off of Amazon. They're real small, 128 by 32. But if you just want a real simple little display, this is a pretty cool thing. And let's see, I thought he was using a.
Hey, Doug, does that little gladiator robot, I was just looking at it on their website for $25. That looks like it's a little bit more capable than the Zumo if you wanted a small tracked robot.
Zumo. I don't like Zumo, so yeah, I definitely would agree with you on that one.
Well, it's got bigger motors. The Zumo's got the
it's
little
got more
M20.
space. It's got more space too. Zumo's too small. Because it was made to be a sumo robot, and so everything is, just packed to the gills on it. It's not something that I particularly like. I'm not saying it's a bad.
I went through that whole pain of actually going to the trouble of installing encoders on one of those, and it, sawing plastic, and it was just quite a challenge. Whereas this looks, the size of the motors looks more reasonable, and it looks like it's a little bit bigger, like you said, not big, but bigger.
Yeah.
And
anyway, they have this. He's showing. There's a website where you can train your model on, and so in his case, he's trying to pick up trash. So it's got how to go to use the on-web model to pick up trash. Here, I guess this is the actual website. Let's see. And I'm trying to think of so that's all part of that. Oh, he's using a Raspberry Pi 4. I knew he was. And so he's using a Raspberry Pi 4 to do his AI functions. And goes through that step by step. Then he talks about how to use the LiDAR, which looks like he's setting that up. So I think he's using it mainly as obstacle avoidance, but I'm just saying for a given little instructable, this sucker's got a lot of meat to it. And so I'm looking at how he's doing that. And then finally, for the end, he puts that nano I told you about to determine, you saw how tall his robot was? Well, apparently it can fall over. So he's got a little tilt indicator, and if it falls over, a beeper comes on. And oh, this was cool. He also talks about using this LCD assistance, which allows you to design characters for your OLED. So in his case, he creates a little, looks like a meter. Let me see if I can find it. I think he has a picture of it. 6 more images. Okay, see this little meter here? He uses that LCD assistant to design this, and then he just puts it into memory. And this is just that little sensor I was telling you about. Unfortunately, you can't pay $2 and buy one. You can pay $6 and get 3, just that sort of thing. So anyway, and here you can see, here's the little box. He's using the DF robot because he was sponsored by them. So anyway, I saw this and thought this was really a meaty, instructable, worth people knowing. And I'll get to the top so you can see the title. it's a litter detection robot with edge impulse.
And I put a link in the Slack. I found it.
Okay. So anyway, a meaty thing. And then the other thing that I thought might interest people is Instructables has just opened up a robots contest. So if you want a shot at winning a couple of $500 gift card, or that's probably you have to be pretty lucky for that one. But there's 21 prizes, and there's 300, 250, 150, 50, and that's 10 runner-ups. And I have placed in these type of contests a long time ago. They're fun. Writing up your project. Does give whatever you've got. It's going to be completely open source because it's out here for everybody to copy. But anyway, some people might be interested, and so I just threw that out.
So what's the subject of the thing? Just do something cool? Is that the contest? Do something cool?
No, it's just has to be a robot. Like, okay, it could be see this robot statue? It could be that. Or it could be that tilt robot I just talked about. That could be an entry. Okay. It has to be all homemade robots, as well as any other robot themed projects are eligible. Okay. I actually, in one of the contests that I was in, I actually won iRobot Create from it. So that was pretty cool. So, I mean, it can be something that it's doable. You can win on one of these things, or at least be one of the 21 prizes.
What's the deadline?
It says it's got 55 days left. So it's about 2 months. And they have, if you use Tinkercad or Fusion 360 in the design, then you'll be eligible for special judges prizes. Okay, so they probably don't, I don't think anybody here probably want to use Tinkercad, but this might, you don't have to do the whole thing in Fusion 360, but if you do some of it in 360, you just mention in your Instructable that you're doing it, that you did this in 360. So anyway, I just thought that's something that I saw that I thought people might be interested in.
So I could even enter my robot spider for that, huh?
Yes, you could. Except, didn't you write an Instructable on that already?
No.
Okay, yeah, you could do that. That'd be really cool, because this is going to go through Halloween. Yeah, that sounds like a real cool possibility.
You
Yeah.
could nail it.
Yeah.
We'd give you some respects on that.
Yeah.
And if you want to share the prize, hey.
Yeah. Well, I wouldn't go that far.
Oh, no? Okay.
I wonder if my Mr. Big Head, I hadn't written it up anywhere.
Okay.
Qualify.
Do it.
Yeah, sure could. Yeah. And I will say this, if you look, let's see how many, I have 9 Instructables out there. So writing an Instructable, a good Instructable, is a good way to do in fact, I often thought if you could somehow write an Instructable using software that was like Instructables, but not Instructables, something that you had yourself, it would be a really good way to document your projects, just like a notebook. Anyway, let's see. So I talked about the robot contest. I talked about this really good one. I talked about, okay, by the way, this is the name of the website, is wit-motion.com. and you can look at that and see all of the different products they have. They have some that they claim are military grade sensors. I buy that with a real grain of salt. But like I say, I'm going to evaluate this guy and see if he'll do at least the basic run the robot in straight lines and do what you need to do without any problems. You can see they have, here's what they claim: advanced Kalman filters, 32-bit processor, 200 hertz data output. This one they're claiming it's using this particular compass, and this really got me kind of interested just to know, because I haven't looked it up to see. But they claim that they claim in other things that this, oh yeah, here it is, which barely affected by the magnetic field interference. So I don't know if supposedly this thing has some sort of way of filtering out some of the problems that you have with magnetometers. Yeah, and so anyway, and you can see over here in this picture, you can see that they have a built-in calibration. You can see the circles. So anyway, and they they provide STM and ST and Arduino and Raspberry Pi examples, supposedly. So, but since most of them are using some form of the serial port, most of the examples are simply reading data off the serial port. All right. Let's see. Was there anything else that I wanted to talk about? Oh, I guess since I haven't talked about it in a while, I am making progress on my mapping program for my robot. I don't have anything to show yet, but getting close. There's let's see what else. I've got some visitors coming to our house, and my wife has got me doing a whole bunch of honeydews. I'm out there washing windows the last 2 days.
Doug, I don't know how you got anything done with all that. I mean, that's
well, you can see. Well, about all I did was, did this 3D printing and play with the angles, and I also did some refinement on my mapping program. But that's about it. I mean, this other stuff is just stuff that comes across the desk. And if you haven't, I've stressed it last week, and I still think it's a great deal. If you want to go for the Oak-D Lite, its Kickstarter is now over $500,000. And so they've added a couple of goodies. They have like stretch goals. They've added several stretch goals. So it's really starting to look like better and better and better. So if you haven't jumped in, you might consider it. All right. That's it, Carl. I'm out of here.
Okay, cool. Can you put a link for that thing you just mentioned in there? And
Hey, Carl?
I was going to mention I did put a link in for my thoughts on mapping and navigation. There's no program code. It's just a document I made up about how I'm going to do the program.
Okay. Oh, by the way, I did, when I was looking at this other guy to have his link show up, Instructables just dropped a telepresence robot the last day or so. I haven't even looked at it, but it looked like a tank robot, but it's a telepresence with a phone on it. So I might get some ideas from it.
Nice.
I don't know. I haven't really looked into it. Okay, I'll put the D-Lite Kickstarter.
Cool. Thanks.
Okay.
Hey,
Carl, speaking of Kickstarters, did you see the thing from the Pocket Pro?
From the what?
Oh, this is It's a Bluetooth DMM oscilloscope thing that Harold and I bought into a couple years ago, and they're finally about to deliver.
No, middle of November, it looks like we should be getting the package.
Yeah.
Yeah, I was real happy about that.
Yeah, this will let us. We can get two, like 1 to 4 of them, and we can use them as individual probes, and then with phone, then it'll turn those probes into a up to 4-channel oscilloscope. Huh.
Yeah,
Cool.
your phone becomes your display
Yeah,
for all the stuff that you do with the probe. It's pretty cool.
it's pretty cool.
Neat. That would definitely
It
be
does.
portable.
Yeah,
Certainly.
Kickstarters are fun when they deliver, if and when. But
If and when.
This is only about 1.5 years late, so you know.
yeah,
From
Better
what
late
they
than
predicted,
never.
but it's all right.
hey, I think so. Doug D, you had posted something on navigation. Did you want to describe what that's about and tell us a little more, or just let the blog post stand for itself?
Well, the blog post pretty much stands for itself. I can bring it up and share the screen, but let me do this real quick. So I think you're probably seeing my screen now of the blog
Yep.
post.
Yep.
So basically, this is just my thoughts on how I would do the mapping, because Doug got me thinking about it, and so I decided I would formalize putting it down. And future blog post, I'll actually talk about the code I'm going to write. But basically, I kind of make a brief statement of what I think mapping and navigation is, and then I describe how I'm planning on doing the mapping. And Doug got me thinking about it, because he was talking about updating his little 6x6 map as he goes along, and he drew some pictures about as he makes a step, he's updating yet the next squares and everything. And so I kind of formalized, that was very similar to what I was thinking. So I kind of formalized what I was thinking about. And it talks here about, well, you update your master map based upon what your sensors are telling you at the time. And eventually you get a map that's full of two types of objects. One is objects that never move, like a wall. And then the other type of object is an object that may be there and may not be there. And so that kind of object, as you're going along, if you find that square is empty, you take it out of the map. And if you find something there, you put it in the map. And then with the map, you get to the navigation part, where you're going to say, okay, I want to get from point 1 to point 2. Let me plot a path through all these known objects, and I'll do some object avoidance on the way just in case something's moved. But this is how I'll do my map. And you can do it kind of one step at a time, and you can plot it all out before you start moving. And I talked about both those types of options. And then I talked about this debugging tool that I was planning on writing, because I work in Windows Forms objects quite a bit. And so I'm going to write, sorry, Linux guys and Mac guys, but I'm going to write a Windows program that I can write out the data file for the map. And then the DPRG remote control software that I defined, it actually spits out some stuff that will be very good for this debugging, because it spits out what the sensors are reading as a string that can be decoded. It also spits out what the commands are given by the robot to the motor, so that you can basically simulate what the robot did and maybe figure out what went wrong. So I talked in here about how I'm going to pull that off. And then what I'm going to do over here is I'm actually going to write the code to do those 3 things, and I'll eventually do future blog posts that do all of that.
Cool.
So it's a start. So hopefully I unshared. Yes. And we're back. So I'm planning on working on my telepresence robot in the near future, and it eventually will implement those things.
That's pretty cool.
And I'm trying to get the telepresence up for November so that I can show SRS.
That'd be good. Yeah.
And maybe writing instructable. What the heck?
There you go. Yeah. I mean, you put enough time into it. It's
Yeah.
got some cool things going on with it, and it's different enough. Why not? Well, good. Okay, thanks. Let's see. And Doug, thanks for putting up that Kickstarter depth camera thing. That looks like fun. Kareem, were you raising your hand?
Yeah, I got something to share.
It looked like you had some kind of big demo going on there. What's going on at your end?
I wouldn't say that, but so two different things. One is am I not? Can you?
Your microphone is not. It's like your laptop microphone is to the boom mic.
Let me try changing my settings real quick.
Like if you tap your boom mic, are you getting the sound into the right mic?
Is that any better?
Oh yeah, much better.
Sorry about that.
It's okay.
Yeah, so I got two things going on. So one is the robot, the FTC season for my robotics team was kicked off last Saturday. And then I was going to show a little bit of vision processing stuff. So let me share this. I'm going to subject you to a 1-minute video that the team produced. They did a robot in 2 days kind of a effort. So they learned about the this year's challenge on Saturday, and this is what they come up with.
I trusted you. Now look how it all turned out. I'm all the things you never cared about. So save yourself from the kiss. They're having way too much fun as it is. 'Cause I don't ever think that I could talk to them. I'll sit alone again. Just leave me be. So why don't you just leave me be? I trusted you. Now look how it all turned out. I'm all the things you never cared about.
That's quite the light show going on there. Very nice.
They decided to really amp up the visual processing on that to make it archaic or something, or bad video from the 70s or something like that. I don't quite get the artistic choice there, but that's what they chose to do.
It's what the young people today do, Kareem.
It's what they do. Yes. All right. Let me switch to something else. I got to stop first. I'm not going to take you through unless somebody wants to see it. They produce a game animation each year about what the challenge is. You probably got a sense of the primary things that they've got to do. So they threw together a robot really fast, and it's not like a competition ready robot, but it's a good start. And they got something. They're probably going to crack through 1,000 views. They just released it yesterday on it. So. It's got some notice in the FTC community, and so I happen to have the field sitting here behind me in my living room at the moment. And I also have the robot that I brought to the challenge in August, sitting in there, and I was gonna show you. Let's see, is it on? Let's make sure it's on. Yeah. it's turning. Okay. So I was going to show you the visual pipeline that I'm starting to get going for object detection. So sort of equivalent to what Doug was doing right now with the sharp sensors. So let's open up the dashboard for that. So this is what the robot is actually seeing right now. So if I move the robot a little bit, you can see. Let me switch to a slightly bigger view. Can you guys see that?
Yeah.
Okay. So this is the vision pipeline. This is a pretty standard OpenCV custom pipeline. We can get a look at different stages in the pipeline. So this is the camera view. This is what the depth camera is seeing right now. I don't have the color camera integrated with this option just yet to visualize it. But the mechanism that I'm using, I talked about previously, is that I've got this floor image, right? So this is my reference image for what just looking at a mostly blank floor looks like using the depth camera. And I'm subtracting the two of those in order to see what the difference is. And then it's just about sort of thresholding it, making it more obvious what those items are. I'm going to skip over a road because that's not coded quite right. And then this is the actual contours. So as the robot moves around, changes view, right? It's going to see these.
Contours at a certain depth.
A contour is a contiguous region, just a contiguous region of pixels that from like this earlier stage, let's go back to threshold. It's basically finding continuous sections. So the threshold operation just makes it sort of simplifies it a whole lot. At this point, we're dealing with just a mask and not the actual depth information. But the idea is, so this is not a finished pipeline, but the idea is the next stage beyond this is to use the contours that it finds. So right now, so for example, this right here, can you see the cursor as well?
Yep.
All right, so this right here is actually one of those trays that are part of the obstacle, but you can see that it's merged with this background stuff, which is actually the countertop. And so it looks like one object, and it's actually representing things from many different depths. So it would be improper to treat this as one contour, so the only purpose here is collision avoidance, right? So the only thing that I really care about is which items are closest to the robot and in the direction of travel. So what the next stage is to take this contour, reapply it over the original depth image, find the closest pixel within that contour, and treat that whole thing as a barrier at that closest distance. Because I think generally that's going to be sort of a good enough approach. And all I'm trying to get out of this is really just a single value. After processing this entire pipeline, all I want to do is hand over a very simplified virtual sensor reading that basically is a vector that points either left or right, -1 to +1. And the interpretation on that is if you have a very large value in either direction, you better divert away from that. And the direction is going to be a hint as to which is a better direction to divert towards. So this is a far from complete pipeline. There's another, I don't have a good graphic of it. I've got an image of something that I wrote up on a window, and it's just got too many reflections, so I don't want to really show it right now. But I sort of laid out the next stages of processing to get a better sense of what's the right hint to give to the navigation components. So I'm trying to take a lot of very complicated information and simplify it down significantly. But just want to share that. That's where I am with the obstacle detector for the robot. That's all I had to share.
Coming along.
Very cool.
Yeah.
Thank you.
Huh. Very nice. So is that your pipeline or is that the kids' pipeline?
This one happens to be mine. We
Okay.
use the same sort of API. So my robot is running on a and part of that is to show them how they can do these kinds of things. But they've done pipelines that complex in the past, and so this is not really. This is more about sort of preparing the. We're going to get a bunch of new recruits starting next weekend, and this is about starting to teach them about some of the options with non-competition robots.
Cool. So it's something else. Very nice. Thank you.
Hmm.
All right. Who else? Who else? David Anderson, raising your hand. What you got? Unmute button.
I've been doing a little bit of sort of wag the doll research here, looking for proof of my preconceived ideas. And Kareem and I had a talk a few months ago. The topic at the time had to do with robot braking, and you can configure your H-bridge depending on what motor controller you have, basically so that it shorts the motors and you have electrical braking. And my observation was that I thought that that a PID controller actually does that without any alterations to the H-bridge, to the motor controller. And Kareem said that he'd actually seen that in telemetry stream coming back from one of their robots. So I set about the process of trying to see if I could force that to happen. And let's see, how do I do this? Let me share my screen here. Did that do anything?
You're presenting now.
Okay. You all bear with me here. Are you seeing a video?
Indeed.
Okay, let me start that over. So this is just a really, really simple little test. And what the robot is doing, it's accelerating in a straight line and then slowing down and coming to a stop and turning around and coming back. So this would be like a nominal run where I wouldn't expect to see any dynamic braking. So this was kind of my fiducial test that I was going to compare others against. And so not much to that, just slow down and stop. Okay. So you should be seeing a graph.
Yep.
Okay. So what that run you just saw, I was logging everything, and when I finished it, I dumped the log and created these plots. And so here's the first one. The green graph line is the acceleration. These are basically the inputs to the motor control command. So you have an acceleration or a velocity and a rotation. And you can see that can you all see my cursor?
Yes.
Okay, you can see that there's a linear acceleration up to 40% full speed. And then when it gets close to the target, you can see a nice graceful curve as it slows down. And we'll talk about this here in a minute, where it goes to 0. Then you can see the green stays at 0 while we go through this rotation. And then the second green hump there is coming back in the other direction, and then the final turn back around to where it begins. Let me blow up this little piece right here. And what you can see is as the velocity slows down, there's this sudden little funny bump here at the end that goes to 0. That's a little tweak. You can tweak the size of this bump and the size of this slope here to guarantee that the robot actually stops exactly over the waypoint.
David, is that
Yes.
measured acceleration and velocity, or is that commanded?
We'll get to that. This is the command.
Okay.
Okay. So that's what the velocity does. The rotation, you would think would be driving in a straight line. And Ted, I remember you asked one time, why doesn't the robot wiggle back and forth on its way to the waypoint? And I said, well, it doesn't because there's a dead zone in there. But that's only a partial answer. The complete answer is that it does wiggle back and forth. Just like when you're driving straight down the highway, you're making tiny adjustments on the steering wheel in order to keep it pointed at the waypoint. So that's what you're seeing here, is the, tiny adjustments made to continue. So those adjustments, they're very, very small, and they're all inside the dead zone, and so you don't see them. So it looks like the robot's going in a straight line. Then you'll see here that both of them go to 0 for a while. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So about a half a second. Hopefully, we'd like the robot to stop moving at that point. Then we have a linear acceleration for the rotation. So the velocity is 0, and we rotate around to 20%, and then we continue to rotate at that. And then the down ramp is just like with the velocity. You're measuring the distance to the desired angle. And so you get this nice curve. And then there's a little back porch on it here where it's just barely turning at all. And then when it arrives at the angle, it drops to 0. So is that clear? Does that make sense?
Mm-hmm.
All right. Now let me jump over, and Ted, I think this might answer your question. Give me a minute here.
David, just one question.
Yes.
David, one question. You've got both the little back porch and you've also got the little dead zones. Are those programmed in order to let the robot stabilize?
Well, basically, when the robot's moving toward the waypoint, you're whether you're trying to reach an angle while rotating or to reach a point while driving, there's some point at which when you fall below that, the robot just won't move. And so that's a little bit of a cheat right at the end. So you're not actually going down to 0. You're going down to what I call the minimum speed, which is just the absolute minimum that the robot can move. You can tell by looking at that the minimum that it can rotate in place is less than the minimum at which it can drive straight ahead.
Okay. Yeah, I think I've stolen your idea before, because I'm using ship terms. So I've got dead slow, and as soon as I get near where my target is, I turn it to whatever the speed is. I set it to dead slow, and then I creep up to that point. I think I got that idea from you.
Exactly.
Okay.
And that allows you to, you can then tweak those numbers so that it actually does come to rest exactly over the waypoint.
Yeah.
The end of the. Okay. The second is the same thing we just looked at, but now I've actually added the output of the PID controllers. The pink empty squares are for the left one, and the blue solid squares are for the right one. And of course, the output of the PID controller has got to contain both the velocity and the rotation, as well as reactions to what the wheels are doing. If they're going over bumps or high friction or something. So you can see here the two of those climbing more or less linear. I've spread these out a little bit so that they don't lay on top of each other. And I want to look right here at the very beginning of this. You can see that there is a big jump. Basically, these motors, fully loaded, that is with the gear head on the wheel and the weight of the robot on them, don't actually begin to turn until about 12% power. So 12% power is treated like the first step of a linear step. So when the thing is 0, it's 0, but as soon as you go to 1, it jumps up here, it jumps across that dead zone, and that's where the what's the word I'm looking for? The acceleration ramp begins. And now if we look at the other end of this, which is the point I was really interested in, you see our acceleration drop down, and you can see that the wheels drift apart here a little bit, or at least the control of the wheels do. Then we get into that dead zone. And at that point, you see our velocity's already gone to 0 and our rotation is in 0, but the PID controller is still pulling down. And when it gets to that point, both of those values drop to 0. Now, since we're going to rotate, one wheel turns one direction, one wheel turns the other. So we actually did have, well, I'll get to that in a minute. But both of them went to 0 here, and then one of them goes negative and the other one goes positive when the robot begins to rotate in place. So my theory is that when you're braking real hard, that value would actually go negative. Hang on a second. Okay, this one includes now the actual, Ted, what you were asking about. This is what the wheels themselves are actually doing. So this is the output of the encoders. And again, the circles that are empty are the left wheel, and the circles that are solid are the right wheel. You can see, for example, here, that even though we do this big jump to 12%, the wheel velocities themselves accelerate very smoothly. You can see here, for example, where the rotation is telling us to turn right. You can see that the left wheel is actually going faster than the right wheel, which is what happens when you turn right. And here, when you turn left, you have just the opposite. So basically, these represent the feedback to this as it responds to these two commands. So if we go look here at the other end of that, you can see that even though we have these sharp drop-offs, that the wheels themselves are actually going at very smooth rates. That's a nice curve through there, even though we have these big jumps. That's what that's there for. Same thing with this one, which goes back positive again. Does that make sense? Have I explained that well?
Yes, very
Real world
well.
physics doing smoothing for you.
Yes. Well, that's the whole point here, is that is the inertia and the momentum of the robot large enough that you actually have to pull the negatives, the signal negative, in order to get it to come to a stop.
That's
Okay.
probably why it's more visible to us.
Yes.
Compared to the typical type of robot configuration I see.
Yes, I think so, because you have big, heavy, or is that your point? You have big, heavy robots.
Yeah, with lots of inertia. Yeah, and
here's the
aggressive
second
driving.
test.
Yeah.
And this one, let me stop and talk. This one, the robot is set to go at 80% full speed, which is about as fast as I can go and still have good command of the steering. And then I shortened the deceleration ramp. On that one I showed you, it was 26 inches. On this one, I slowed it down to 16 inches. So it will decelerate more quickly. So, and you can kind of see it. If you watch carefully, you can see it decelerate. I mean, it looks like it's decelerating. Push your button, David.
So in these runs, did anybody ever come out on one of those doorways and almost accidentally step on your robot? Or?
I have had interaction with them, but the most recent one was a bunch of people making a lot of noise out in the hall with some visitors. And I stuck my head out my door and I said, "Hey, hold it down. There's people trying to sleep in here."
Is that the equivalent of get off my lawn?
Exactly. Okay. So, so I also logged that one. And I'll start with the same display. You can see we have a much longer ramp and we're going up to 800 here. And we don't have as much overlap because it takes it longer. Also, note this interesting curve here. I don't know if you could see it on the video, but when it's going that fast and I slam on the brakes, it slides sideways a little bit. I'm not sure the cause of that, but this is the waypoint navigation correcting for that sideways slide as it comes to a stop. And when we look at the actual wheels, you can see that.
You have slightly more mass on one side of the robot than the other?
I don't know what it is. I don't think I do, but I guess that's possible.
Could be a few grams or something.
Okay, so here is that same thing with these circles representing the actual velocity. And if you look down here, it's exactly what I was looking for. That is to say, let me spread this out so I can untangle it a little bit. But here's our velocity coming down and going to 0. And here are the two outputs of the PID controllers trying their best to slow these wheels down. The data points line up vertically, so the velocity is well behind the corrected velocity. And when it gets down here, you can see that it actually does go negative for 1, 2, 3, 4, 5, for 6 values. And you can see it real steeply pulls this, I guess that's the right wheel, to a stop. And then the right wheel actually spins backwards. See that right there? Which I don't detect at all in watching the robot move. But this is the same thing for the left control, and it also goes negative and then goes positive. And you can see that it's actually pulling that velocity real hard towards 0 and pulling it slightly negative. And when it goes negative, the control goes positive and pulls it back up to 0 and then drops back down, and we're back where we started from. That may be the beginning of a little oscillation. I'm not sure. But it does seem to be the case that the PID controller itself provides electric braking if the robot is moved. In my case, I had to make it go really fast because the robot's very lightweight. In Kareem's case, because they're dealing, and Pat, this might deal with you also, since you were asking about 125-pound robots. But I think that it actually is the case that the PID controller itself provides, let's see, stop presenting.
David, do you think this would be, go ahead.
It provides the equivalent of electric braking.
Do you think this would be true of any PID controller, any normal PID controller?
You have to have a D term in it. So the more
Yeah.
aggressive your D term, the more pronounced this will be.
Okay.
But
That makes sense.
Is it, so you mentioned the term braking when you described this, but is that really just showing that the loop is a little underdamped?
Okay, think about what happens when you do electric braking. Basically, what you're doing is instead of the battery charging the wheels are charging the battery. You're using that power.
Right.
So if the robot is running along, let's say at 100%, and you power it at 3%, then the total current is going to be flowing the opposite direction. And when the current is flowing the opposite direction than when the wheels are turning, that's electric braking. That's what electric braking is.
I was kind of curious. Do you think for an abrupt stop, you said you didn't see the robot frame, go backwards, but do you think the wheels could be skidding?
I think that's what's happening.
Yeah.
I think right there at the very end, the wheels are slowing down and actually rotate backwards just a little bit to bring it to that abrupt stop.
Right. Yeah.
I see ours slip all the time in hard stops. Yeah.
Well, the only way I could make this happen, as I said, was to run it as fast as I could run it and to make the down ramp, the deceleration ramp, really short. If you run at full speed and then just stop, any 3-wheel robot will tip up on its nose.
Wheelie bars.
Yeah, exactly.
Ooh.
That's all.
Huh. So you're just a step away from regenerative brakes then?
Well, okay, you guys, some of you probably have robots that if you grab the wheel when it's turned off and spin it, some LEDs light up on the board.
Oh yeah.
Everybody said that?
Yeah.
Yep.
So you're already set up to do regenerative braking. You just have to be putting less power into the motor than is coming back.
This is not regenerative braking, though.
That doesn't
This is
count?
quite the opposite. No, because you're actually applying power in a negative direction ahead of it. So this is active. This is definitely active braking, and so you don't get any. You're still drawing on the battery.
I was suspicious that this was happening, but I now feel like I have proof that it actually does happen.
I would concur. Chris,
Thank
you're
you. That was
mute.
very cool.
Chris, your mic must be off.
But David, thanks for packaging it in a very easy to digest way.
And colorful graphs. We like colorful graphs.
Very much so.
Graphs, yeah.
Quite illustrative.
Chris,
Yeah.
can you post your question in sign language or on the chat?
But thank you, David. That was very. I mean, getting our heads inside of a PID controller is, it's sometimes I won't go there, but it's having spent a little bit of time in a PID controller, it's nice to actually see it graphed out like that and understand a little more about how it's working.
And I saw that, Ray.
What's
Mind your language.
Good thing that's not in a recording.
Yeah.
Okay. Well, very cool. Very cool. So, all right. Then anyone else? What would be next in line?
I'll go.
Ray, what you got?
Okay. Well, first, Doug, I wanted to say that when you do have visitors, it is very important that you show that you're a clean living individual. So that means clean windows, mopping floors, dusting inside, all those things. I had a family reunion probably 10 years back now, and my half brother and his wife came from Arizona, and we had, I was still building or finishing out the inside of the house that we live in now, and in the category of impressing your visitors, she looked at our kitchen sink and she said, "Wow, they put in a Kohler sink." And it really was not a Kohler sink. It was an IKEA sink that looked like the Kohler sink. The Kohler sink was like $1,800. The other one was like a little less than $300 from IKEA, but they looked very similar. And I never corrected her. So just kept my mouth shut. Yeah. Kohler sink, Anyway, I've been working on the ESP32, and one of the features that's kind of neat about the part is that you don't have to stick to the physical pins where things come out on. So if you don't like, the position of the I2C pins, you can map them to other pins. Same thing with UART and with SPI interface. And I could find examples. Well, the part that I bought, it's a TTGO ESP32 with Aurora radio on it and a small LCD. So all those things, take up quite a bit of the pins because they just need that many pins to work or to operate. And one of the things that they did is they put the OLED reset on the UART receive pin. So you basically couldn't use the OLED if you were using the UART. And I looked at some examples on how to map pins, and they all seem to work, except there was no example for the UART. And it's not the same as, setting up a serial port in, for like a Mega or any of the other ones. So I finally, I don't know, somehow stumbled on an example that had code that basically told you how to remap those pins. So now I can use the UART again because I mapped them to two other pins, and I can also use the OLED that's on the board, which is kind of nice because it has it. It's the 128 by 64 OLED, and I was using an external OLED off of that's the OLED on the ESP32, but this is just an external OLED off the I2C bus, and it had a BNO055 on there. So now I'm able to actually use the serial port because that's what I am using to communicate to the RoboClaw controller. So I really wanted to use the OLED, wanted to use the USB, or not the USB, the UART. And for a while there was like pulling my hair out because I couldn't find any examples on how to do that. It's, I thought, okay, well, I'll just look on the Arduino IDE, the reference or the documentation. Didn't have anything about ESP32s and how it's set up differently, and how to remap the pins and all that stuff. But it's basically done in the serial begin statement. It has a few extra parameters that you set. So that was a little disappointing. I thought, this thing's been out for a while. You'd think there'd be, plenty of documentation on it, and either I was looking in the wrong place or something. It just didn't seem to be, documented at all. And it's really pretty simple. You just specify, it's like the mode, 8N1, 8 bits, no parity, 1 start bit. You specify the receive pin and transmit pin. You can even do like request to send and clear to send if you want those signals as part of the UART. But I can't remember the last time I used those two. It's just RX and TX. So it a little surprising that I couldn't find it that easy. But like I said, eventually found an example.
Hey Ray, could you put that link in? Put that link in chat, because that, if you had a hard time, it probably is hard to find. So go ahead and put it in chat if you can.
Okay. Well, it's not really. I'd have to find the example again. I think it was on Random Nerd Tutorials, but it doesn't. It didn't say. Here's how you set up the serial port if you want to remap pins.
Yeah.
It was just a sensor happened to be have a UART connection on it, and I said, oh, okay, well, there's a couple extra fields in here. What are those for? Turns out that's what it was. So,
Ray, can you assign those to any pin, or is there a subset of pins that it can be assigned to?
Yeah, there's it's a subset on the ESP32. Several of the pins are input only. 1, 2, 3, 4, 5, 6. Actually, 8 of the pins are input only, so you can't assign an output to it. I guess it's the structure of the pin. It doesn't have it's not set up to be an output.
Well, I know on the ARM chips that they have what are called alternate functions. So
yeah,
is that similar to what you're doing?
There's God, what is it? It's like an output multiplexer, so you can basically remap any of the functions, to other pins, and it doesn't have to have. It's not like it's a hardwired alternate function. You can map them to any pin that.
Okay.
Like the UART pins don't have to go to other UART pins. They can go to
So TX,
the matrix.
so like TX, So like TX can go to any output pin and RX can go to any input pin.
Yeah, if you wanted that, or if you had to do it, like here, I'm using GPIO 12 and 13, which are touch inputs, and ADC2 4 and 5 inputs. It's got two ADC controllers, or peripherals in it. So yeah, I thought that, I don't know. Like I said, I just might not have been looking in the right spot, but I did, and I was hoping for the old Arduino equivalent of the Arduino cheat sheet for the ESP32. If the functions are different than what they are for everything else, but haven't seen that yet either. So that's kind of a nice thing if you just forgot or don't want to dig up an example where you used it before and haven't used it in a while, just forgot how to set it up or something. So, but so far everything that I've tried to do, I've been able to do. Using I don't know if there's going to be an issue using everything. Like if I use the LoRa radio and I2C, well, LoRa's on SPI, so that would be using SPI, I2C, UART. Hopefully, there's not some other issue there that something stops working because you're using so many peripherals or something, or there's not a timing issue or something like that in the code. But anyway, it's pretty versatile. Dave Anderson, you were saying some of the ARM pins do that, or ARM processors do that as well?
Basically, if you look up in the, there's some nice tables. You say, okay, I'm interested in looking at timer 2. And timer 2 can be connected to the outputs 12 and 13. Or alternate function, timer 2 can be hooked up to 2 and 3. Or third alternate function, it can be used as a quad encoder. You use these 4 pins and so forth. So you can't it's not like a multiplexer. You can't arbitrarily assign it just to anything you want. But it is kind of a puzzle. You sit down and say, well, these are the things I need to do, and get it all arranged, and oh no, I don't have a port available for this. But if I move this one to over here and move this one to there and then move this bit to there, then I can get those two. So the only ones I haven't used, I don't, on this robot, I don't use any I2C, but there were 2 pins unused. And so I arranged that those were 2 of the alternate function I2C pins in case I wanted to use it. But it's not as flexible. Dave Ackley showed me one time a graphic program. Was that the Smart Cube stuff, Dave? Where basically they've got it all built into a program, and you click on things and it'll tell you which pins you can connect it to.
Was that the
Cube
STM32Q?
Yeah, Cube MX.
Yeah. Anyway, so I had to. My wife and I volunteered at food bank, and one of the guys had breakthrough infection. So last Thursday, end up with a sore throat, and I think, oh God, I've caught it from him or something. So I had to go in, get a COVID test. My wife has been like living in the other part of the, other places where I'm not, got the results back of the thing, and apparently I caught a cold. So it's, so, but apparently Colbert had a thing and said colds are now coming back. It's like they're in full force. Everybody's catching colds.
Has she been vaccinated yet? I know you told us they told her she had to wait like 30 or 60 days or something.
Yeah, she's been vaccinated for a while. And I've got my appointment for my booster already. I don't know if anybody else has got one.
My wife got one, but since she has cancer, that's a no-brainer.
Yeah. Yep.
My mom got one, but she's 95.
Yeah.
Mhm.
Well, it's supposed to be open to, individuals 65 and older or with compromised immunities.
I hate it that I and my mother are both considered old people.
Hey, Carl, I have something, if a little something brief here. I still got a slot open.
All right, John, jump in.
Little cautionary tale on the use of super glue. And no, it's not what you think. I didn't get anything stuck to something that I shouldn't have. But if you're tempted to use super glue to super glue plastic parts together, be aware that super glue reacts with some plastics. And I made that mistake yesterday. I've got this slider board that has these two limit switches on it. It's all surface mount, all right? And I was a little concerned that those surface mounted switches, they only have two points on the board with very little surface area to hold them in. So I was concerned that if they snag on something that they could get snapped off. So I decided to put a drop of super glue underneath. And overnight, next morning, I noticed there's like a white residue all around the switches.
Yeah, I've experienced
None
that.
of the switches would move anymore. So I had 9 of these boards, and I basically desoldered the switches and throw them all away, and do it without super glue. So be aware of that.
So what I've experienced that, yeah, it's really bad if you have like optics and you glue them together and it frosts over the, like a plastic lens or acrylic rod or something like that.
Yeah, I think there's actually vapors that react. It doesn't even have to be liquid contact. I think that the vapors from the drying glue will affect plastic.
Yeah, I don't know what that is. I know if you happen to get smell it or get a whiff of it, it's it'll burn your nose. So I imagine it's probably not the best thing to be accidentally.
It's nasty stuff.
Yeah.
Probably,
yeah, that's scary.
Epoxy is probably a better choice for anything in your project.
Say that again?
Epoxy is probably a better choice for gluing anything in your project.
Or if it'll hold hot melt glue, maybe. I don't think reacts to many things.
It sort of sticks for a while, at least.
Yeah.
I don't allow my team to use hot glue.
Okay, so no hot glue and no duct tape. What do you use as a fastener then, Kareem? What's allowed?
Zip ties. Robot's entirely made out of zip ties.
Wow.
A couple of holes and John could put zip ties. They make nice small ones. There's all different sizes.
I like to use nuts and bolts because I want to be able to take it apart.
That's a pretty darn small part. Hey, look at the size of my finger. You're not going to get a zip tie.
They make very small zip ties.
Yeah.
We have zip ties that'll work there.
Yeah.
Well, besides the way this is meant to work is that's the reason it's surface mount is I got this slider on top here.
Yeah. Okay.
Okay.
So your slider thing will rule that out, but
so you need a countersink 2mm screw.
But I got I found on this. I got even 3-inch zip ties, and I bet if I looked closer, I could find shorter ones, smaller ones.
Yeah, I have something like that one.
Couple bucks, and you get like 1,000 of them. It's pretty cool.
Yeah, when Mr. Tanner was closing down, I was there at the very last weekend, buying some parts and stuff. And Mrs. Tanner said, "Hey, why don't you go down to that last aisle there and pick you up 6 bags of zip ties?" So I got 3 of the really long ones, a couple of small ones, shorter ones, and that kind of stuff. Like I got zip ties, unless I build a whole robot out of them. I got zip ties for, I don't know, forever almost.
Yeah, you can zip tie a mattress on top of your car and carry it down interstate.
Yeah, that's a good idea. Well, no. I don't need a zip tie. I'll just drive down and hold on to it because I got the guns right there. I'll just hold on to it and go.
Yeah, every passenger has to hang on to the mattress. Right? All four of them.
Harold, when you say Mrs. Tanner, is that Jimmy's or Jim's wife? There are
Jim's
three
wife.
Mrs. Tanners.
Oh yeah, that was Jim's wife in this case because I did realize my error once you started talking about when you said that. I'm like, oh yeah, that could have been a whole bunch of them, right? So
Yeah, and I think they called Grandma Tanner, who knew that stock forward and backwards. It was always great to see some engineer go in there and ask her condescendingly about some part, and her rip back, do you want TTL or,
yeah,
I think they called her Mima.
And what's funny was I went in there. I was buying. I don't know. I needed to buy a whole bunch of 9-volt clips for some stuff I was doing for a school that were putting some 9-volt batteries into Play-Doh and making LEDs lights. It was fun. But and I said, man, I got to buy 100 of these. Can I get, they're like 25 cents a piece. Can I get them for like 20 cents? Because I was trying to get a deal. And Grandma Tanner goes, oh, I don't know about that because she knew. I know she knows what the price was. But Jim was like, no, you can have them not 20. Yeah, I'll give it to you for 17 cents. I'm like, hey, I'm tempted to listen to Grandma here. And he goes, no, we're going to do this. I'm like, okay.
Well, that was one of the wonderful things about Tanner's. You go in there and spend a couple of hours and go up with your arm load to the counter, and it's, $8.40.
I do think I spent like $110 in there one time. And I'm like, because I was buying a bunch of stuff. And I'm like, I can't believe I spent this much in Tanner's at one time. How is that even possible?
4,001% resistors.
Yeah, exactly.
Mr. Harold, you been doing anything last week?
Yeah, not a whole lot. I've been messing with the web page for Mr. Bighead, and I will tell you my Twitch streaming. We've been averaging in the last 2 or 3 weeks 5 or 6. Most of the time it's just me and one other person watching my own stream. And here I don't know what's happened, but in the last 60, 90 days, I've gone from an average of 3 to about an average of 6, even though my 30-day average is not that great. But if you look at them on there, because I got some really low ones, but I'm getting 6 and 10 people showing up on a Friday night. And I'm like, this is really cool. And I did get my first payout. So after a year and a half of twitching, I made $105. I'm killing it, man. I'm killing it. No, but I'm working through the web page on here, and I'm introducing my my subscribers and followers into RDD, which is resume driven design, and so we're doing Blazor and some cognitive services, and I got my Twitch bot interacting with it, and some of them are having a good time with it because I'm allowing the VIPs to do a bang MB8, which is the get Mr. Bighead's attention in chat. You can use the say command, and anything after the say, we send it to a text-to-speech converter and have that come back down. And so far, everybody's been nice. So far everybody's been nice. So we'll see how far that goes, that kind of thing. And so this thing is a web page to allow us to change the sayings and also add things like moods, and then eventually using channel points and that kind of stuff to change Mr. Bighead's voice, his mood, or in this case, make it be her mood, because I have female voices available too. And then have moderators and VIP type people or tier levels or something to go in and add snarky stuff or add and change comments. I think it'll be pretty cool when it's all said and done, but we're working through these little things and finding these things out.
You be careful there. Mr. Bighead sounds funny, but Mrs. Bighead might be missing too.
Yeah, well, I'll stick. I do a reboot, and Mr. Big Head comes back. So it's only for short times, and I got the power plug. So Mr. Big Head's got no arms and got no real power yet, as far as I know. So I think I'm okay for the moment. The other thing I'd like to do, and I've got it up there on my GitHub repo for it. I put a bunch of issues up there that's public, and a couple people have gone up there and added some other, and they're not really issues, but things. Hey, could you make Mr. Big Head do this and that stuff? And I'm trying to get some community involvement and stuff, and I think it's pretty cool. But one of the things I got in there is I want to put a microphone on there and have it record stuff. And I have a tendency to use the word really. Like I'll do something. Really? Come on, man, or something. One of these things. And my Twitch people are going like, do you really shout at the screen, really? And I said, I really do shout at the screen, really. You can ask anybody I work with at my work, and I say really a lot, because what they don't realize is it's either really or some other set of words that people don't really want me to be shouting in a workplace. Like I saw this thing the other day. It says, "Yep, I would be sitting on the back of my yacht drinking out of a drink with an umbrella in it right now if I'd only started my swear jar when I was 20 years old." I make a mess, man. I make a mess.
That's awesome. Hey, Harold, what happens if Mr. Big Head could detect every time you say really, and then it could echo back at you? So you'd say really, and then Mr. Big Head would go, really?
Yeah, see, that's what I was thinking about. It could, because I did a look up on that, I did some research, and there are cognitive service type things where I can change it. I can train it on certain words, much like how computer or Echo or Alexa or any of those, or Hey Google, those kind of things. So I can put that in there and have it listing, and then have it have a list of really snarky things like, really? Yeah, really, man, you messed up again, or something. Just any of those things, right? And that's going to be a ways in coming, because I've got some other stuff to do at work. When I say do at work, I've been commissioned to build a big smash button for somebody with Bluetooth enabled to do some stuff, and that ought to be fun. And I've got, I think, I've got a couple other projects coming in the lab, but I've already decided that I'm taking a break from the robot per se robot. Unfortunately, thanks for the contest that Mr. Big Head might get an Instructables thing put in together if they think that's cool. Because I think it's everybody that's shown up here that is streamed on my channel that I know of, that they have thousands and thousands of subscribers. And Bald Engineer, his name's James, he's from Element 14. He shows up every now and then, and I was showing it off the other day. He goes, man, that's so cool. That's really, really cool. So if I get a cool factor out of him, and he sees all kinds of cool stuff, I should write this up, because it's got 3D modeling in it. It's got all the stuff. But regardless, though, I'm going to do a couple of projects, take a little break from the robots, and then probably get back on the rover, because it's a platform. It's got all the bits and pieces, order some new bits and pieces for it, and save it just the way it is so we can show it off. And I do mean we, because I'll bring it to our events. We have them. And then start, not really start over, but take all the stuff I've learned and do a ROS 2 version of this thing that does other stuff in it, and see if I can make it smarter, and see if I can make all the GPS stuff work. And I was having such trouble with Python versus, dragging bit data in that, oh, this just works if you do this. I can't do this because the versions are all screwed up, and see if I can't zero in on a version that allow me to do all those things. The next thing, and set up a little thing and then plink away on that stuff.
Harold, you might, back in the last century, I worked for a speech recognition company, and one of the engineers took the speech recognizer, could also do speech synthesis. This is back when linear predictive coding was the big deal. But one of the young engineers in the back worked out like a stand-up routine where the recognizer would recognize his phrases, which were like the lead into a joke, and then the recognizer would supply the punchline. And
that's pretty funny.
what made it work was that it was real fast. It was like a bunch of Henny Young one-liners. And as best I could tell, that was really the only valuable use I ever saw of that technology.
Well, I have envisioned a few things like this with, you know how, if you look at Star Wars, yeah, I know it's galaxy far, far away a long time ago. I get all that. But if you look at the Star Wars and look at their universe, their user interface and their interface to whatever they need to get done is speaking to something, speaking to some sort of droid that's specialized to do certain things and go and that kind of stuff, and it understands the natural language. So I was thinking about maybe doing some of that on here as well. And in that case that you just brought up there, David, we could get up and I could pre-render a bunch of these things, have them stored locally on the Raspberry Pi, and then recognize the stuff and have it just spit things back instantly. That'd be pretty cool. almost like if I could plan it out to have so if I could get enough keywords in the right place and the right generic sort of keywords and knew what he was kind of going to say and knew it, we could probably have a quasi conversation that would almost seem real for, I don't know, probably 30 seconds probably. I got a pretty good voice. I got a pretty good voice now. Listen to him.
I think you shouldn't have gotten out of bed today.
So it's a pretty good voice. It's a pretty good voice. I could change it, and this is the expensive voice. I only get 500,000 text speech characters a month for free on this level. So I don't have a whole bunch, but it's pretty nice. It's British, so it's condescending by the very nature of it. So.
Are you familiar with the ELIZA program from many, many years ago?
Yes.
Yeah, that was an example of recognizing keywords and spitting back something that sounded like it was a conversation.
Yeah.
His exit from his little comedy routine was, of course, this device was called a VET3, and of course the ending was he said, "Say good night, VET3," and the VET3 says, "Good night, VET3." Burns and Allen.
There you go.
Yeah, there was an
Anyway,
old
lots of fun stuff with this thing on here, and lots of I'm gonna mess with it enough where I could change some stuff on the fly, and then after that, we're gonna build some other stuff, and and keep rotating back to it and improving it. You know how that works, how that game's played.
That's cool.
Do you remember the old H&R?
Bye, guys. See you next week.
We'll see ya.
See you next week, guys. Bye-bye.
Does anybody remember the old H&R Block commercials where the client comes in, he looks really nervous, and the H&R Block guy says, "I smell refund," and the client says, "Really?" And the H&R Block guy says, "No, not really." So maybe you could incorporate that into your replies for.
Well, I'm out of here too.
All right, Mr. David. Did anybody else, Miss Kelly? Did you have something, or Ed? Okay.
Carl, I've got just a short response to something that Doug was asking about earlier.
All right.
So this was some time ago. I ran some experiments in which I divided my office and the hallway and the lab across the hall into a 6-inch square grid. It's I think 40 feet by 40 feet. And I drove around with the sonar, and every time I got a hit from something, and my sonar returns not just distance, but also location, calculated from the location of the robot. So I would bump, I had a little byte array, and I'd bump a number in the byte array until it got up to 255, and then I wouldn't bump it anymore. And when I was done with all that, I ended up with by throwing everything away that was lower than 128, I ended up with a pretty robust map of the space. And then I ran Lee's algorithm, which, if you guys are familiar, that was originally written to lay out traces on PC boards back in the 60s. But basically, the way it works is you have, your location, is in a block. And so you number every block that touches your block a 1, and you number every block that touches one of those blocks a 2, and you number every block that touches one of those blocks a 3, and so forth, until you finally hit the waypoint, the target. And then you just count backwards from the target, and you have the most optimal path to the waypoint. And then once I had that, I did dead reckoning. And I played with that for a few months, and I ran a whole bunch of tests. This was some years ago. And basically what I determined at the time was that the paths that it was coming up with were not really significantly different than the paths that the emergent navigation was coming up with without all that map and computation. But anyway, you might want to look up Lee's algorithm. I think that's what he was talking about doing.
How do you spell that?
L-E-E.
Oh, okay. That Lee. Okay.
There you go. It's in, there's a link to it. Maze routing on a breadth first search. Always gives an optimal solution if one exists, but is slow and requires considerable memory.
That was in
According to
1999,
Wikipedia.
though. Now on a Raspberry Pi, it just takes seconds.
Yeah, and considerable memory probably went 128K or something.
Right, that's right.
Yeah.
It's irrelevant now.
Wouldn't these days people mostly use something like A star?
That's a similar.
Which is pretty similar.
That's similar, yeah.
Hmm.
So, and in my case, since I was using 6-inch squares and a 40-foot, 40 by 40 foot, basically that was 80 by 80, which is 64K. And I just, as I say, I just use bytes.
A-star search algorithm. Okay. There's so many algorithms to copy from. Oh, well. Okay.
Well, I'm looking at that, some of those methods for my mapping robot. And one of the thoughts that I had is that, say, David, in your case where you had 40, a map that was, I don't know, 50 by 50 squares, pretty big, okay? You don't really know, your sensors don't tell you what's out there. So if you don't have, if you don't know what it is beforehand, all it is nothing out there. So essentially it will, it'll do a straight line. So that's why I'm kind of thinking that instead of running 50 squares like that, well, 50 times 50, what you want to do, or what the idea I'm playing with, is that you have a vector to where the waypoint is, and in your map of some reasonable number, maybe 6 by 6 or 10 by 10 or whatever, so, or what you can see around you, you know what I'm saying? I know, when I look with my sensors, I can look around me and I can know that these areas are clear and these things are have, and then there's a vector to the waypoint, and so the vector to the waypoint gives you the lead-in square to your local map, your little 10 by 10. So, that's where you temporarily place the goal where that vector says it should be. And then you do your little path around it. And you try to essentially get to where that goal was. But on your process of doing that, your sensors are going to see more stuff. So now you got more walls or whatever you call obstacles, whatever you want to call them in your square. So that's kind of how I was thinking of trying to do that. I don't know if that'll work. First off, I'll probably just start off to see if I can do it with a full map. You know what I mean? I'll just put them close together or make the square so big that it doesn't matter. But eventually, well, that's where I was trying is you kind of carry your little group of squares with you. And like I say, you have a vector to your waypoint. And then you only solve from where that vector leads into your little 10 by 10, and then solve around that. Anyway, that's the idea I'm playing with right now.
Well, this was different than that. You're correct, because I did run, or actually a bunch of runs, to build the map before I tried to use it.
Yeah.
And one of the reasons that I incremented each cell for multiple hits was because you can get aberrant hits. You can get funny reflections. You can get a hit off of a wrinkle in the carpet, but only at a certain angle in a certain direction. So anything that didn't get bumped a significant number of times was discarded.
Okay, I want to say that there was a presentation for the NITO, and one time from the engineer, an engineer did a presentation. He said 3 times. That's what they use. It had to hit 3 times before they said it was real.
That depends on the sensor. So the
Oh
NITO
yeah.
uses LiDAR,
He was using a LiDAR.
I was saying 128 times that it's not real.
No.
It'd be totally different for different sensors,
but and of course, Doug, that doesn't work for moving obstacles.
Well, that's what I'm saying is, in the one that I'm trying to do, it's adaptive. It's constantly remapping your 10 squares. So, if somebody steps into the map, they're going to show up pretty quick. And if they disappear, they'll show up pretty quick. But you assume they're there until they're not there. You know what I'm saying? So anyway, let's see how, like I said, I'm just playing with it right now. Trying to get all of the coordinates, like how you rotate, you want to boil it down, I think. Since in most of these things you either go straight or you go 90 degrees, or maybe if you're really fancy, you go 45 degrees, but you don't do like in your case where you kind of just weave around.
No beautiful, artful arcs and curves.
No, you just said, I'm either going to go 45 degree, or I'm going to go 90, or minus 45, minus 90, or 180. If everything in front of me is blocked, I'm going to go backwards, that sort of thing. And, but every time you rotate, how that map's going to change is going to be different. And so I'm still playing with how to get those coordinates the way I want them to work.
This reminds me, you may remember a poem from childhood. When I was going up the stair, I met a man who wasn't there. He wasn't there again today. I wonder where he went away.
Persistence is one of the toughest things in mapping.
Yeah.
Classifying things into persistent objects and permanent features and things like that. And so, Doug, it sounds like what you're sort of doing is intentionally wiping your memory on a regular basis, and so I'm really, it's more like what you're doing is a short-term persistence of sensor readings, and not really mapping in the traditional sense.
Not in the sense, well, if you map something, let's say you move to where you are because you saw walls, but those walls are no longer within your sensor ranges anymore. You assume that those walls are still there, except you don't care about them because they're gone. Now the real question becomes, though, can you really do that? Because when you try to map back to your robot from the goal, you want it to take a path that makes sense, and not one that's going to trail you to turn around and go back towards the wall that you just forgot about. So I don't know. Yeah, I don't know. I'm still playing with it. I'm learning a lot.
I'm kind of pursuing a similar thing where instead of building a map, I'm going to be kind of following the chessboard algorithm where my squares are like 1 meter, and I'm only going to look at the squares that are in my planned path and everything, and try and ignore the ones that are not on my path, so I can just analyze each 1 meter square and record the sort of the GPS position of it. and build kind of and move like a knight in on a chess set, you know. And so I'm kind of pursuing that because like I'd like my rover to go to the local playground, but to that it's got to cross an alley, go between a couple of houses, cross a sidewalk and a street, and things, and there's like air conditioner units between the houses. So if my GPS are off, I need to be able to use alternate squares. You know, if my square should coincide with an air conditioner unit and things. But I'm kind of pursuing call it a chessboard type of map myself.
Yeah.
Cool.
No, I'm my test robot's really for indoors. So outdoors, I'm from last run, and what I'm trying to do is I found there's a guy that's running autonomous boats across the Pacific Ocean, and he happens to be using an autopilot. Okay, well, not an autopilot. He's using a Pickox, and because he's doing he's having, you know, the commands up to a satellite and bounce back down to his house. And when he has to reset something, it goes that way. So he's really investigated how to communicate with Pickox, which several things that I didn't know how to do. I now have a reference to how to do. So I haven't actually coded it into my program yet, but that's the next step for my rover, is to get so that it can, I'm going to continue, at least on that platform, I'm going to continue using the autopilot and just improve the communications through the ML link, or I think it's called ML link. It's called MAV link, the MAV link communications, so that the onboard mega processor, which is what it's got now, it might turn into something else, but the onboard processor is going to be communicating to everything to the autopilot, you know, like, okay, so that way I don't have to, you remember if you were at that particular thing, you saw me messing with the computer and trying to everything. Now all I'd have to do is store the waypoints, and then I could forget the computer and I could just push a start button. That's what I want to get to.
Boy, I bet you the cartels would love that.
Huh?
I said, I bet you the cartels would love that, you know?
Yeah.
Oh, Ray. New business line. They're going to make this profitable one way or the other, aren't you? Okay.
They're all set to pay the big bucks.
They've been doing it for years, probably.
Yeah.
I thought their thing was submarines, though.
Well, and human life is so cheap to some of them that, yeah.
That's true.
So
Yeah.
But a human will steal from you too.
there's pros and cons. Yep. All right, guys. Any other topics for this week?
I have one question. On this personal robotics server, this Discord channel that I'm now up to about 160 people. And by the way, a whole bunch of like angry old men arguing with each other. By the way, it's not a whole lot different, but
yeah, I've caught some of those arguments. I just kind of step back, you know, grab the popcorn, you know.
Yeah, it's just, I mean, honestly, there's a couple of people that just want to argue with each other, and I don't want to get in the middle. But one of the things we've talked about is that because it's chat just is very ephemeral, and you go to the trouble of like describing to somebody something, and then like, you know, an hour later it's gone. So there's been a discussion there about possibly setting up a wiki. And Carl, since you're a co-owner theoretically of this, I know you're not. Yeah. Anyway, I'm going to set up a wiki. Right? I'm going to set up a wiki, and at first it's going to be a imageless wiki because, of course, text takes up very little space, and I'll just put it on my own personal server for now. Is there any interest in this group of using that wiki as well to put stuff up there for people to, you know, frequently asked questions and how to build a robot and things like that.
Murray, why don't you just encourage them to join the DPRG list? We already have all that.
Do you have a wiki?
You know, a wiki, isn't it by wiki, the definition that is where great ideas go to die because no one ever reads them? Isn't that what a wiki is?
It's whatever you want it to be. Put it this way, it's persistent information, which is a mailing list.
And that's the point I was making, that the mailing list is persistent information. You can go back and read discussions people had 20 years ago.
Yeah, and I you know, I've been
that
on
seems like the problem you were trying to solve. So I wondered if it might be easier to solve it by just encouraging those people to join the DPRG list.
No,
well, I don't have a problem with them joining the DPRG. I guess the thing is that a mailing list. I mean, I've been on Usenet since the 80s, and I've been an email person. In fact, it's funny you say that because I just had not an argument, but I had a discussion with a younger person at work who was telling me I should be using chat at work, Rocket Chat, because he doesn't ever use email. And it's like, so it's a cultural thing, a generational divide. But
and you're an old man, Murray.
I know, and I
want to be
off my lawn. Yeah,
I want to clear up a little bit of things.
But
I was
but
being
let me
snarky about the wiki thing. I truly was, but I think it's a great idea to write these things down, at least someplace where we can reference it. And I still think it's a good idea, even though I think they mostly go unheeded. Like in the
I guess Harold, the point though is that I don't disagree, David, that a mailing list works, but a mailing list doesn't organize information. And you can do a search on a mailing list, but I'm talking about trying as a community to create an organized set of pages that describe, you know, how to build a robot, recipes for soldering, things like that. And I've used mailing lists for 35 years, and I'm quite aware of how, you know, the pros and cons. And I've been on, I think, something like 20 different working groups that have had mailing lists. So certainly, but finding something on a mailing list is sometimes difficult. What was that one? Yeah, the DPRG list. And I'm on mailing lists back to the 90s or even I think 80s that are still online. But finding how to, let's say, write a PID controller, how would you find that on a mailing list? Whereas we could have a page that said, this is how you build a PID controller or something like that. So that's the argument for a wiki anyway. And a wiki was designed, by the way, to create a place for a community to keep information. That's actually what it was designed for.
Sure.
So is anybody here interested? If I was to set up logins for people, would they be interested at all or not really?
Well, are you asking for who would be interested to have access or who would be interested to serve as contributors and like mediators and moderators and builders?
Both. I'm going to probably set up a wiki for this personal robotics Discord channel and offer any of the sort of more stable and less destructive people logins. That's a hard one, I know. And then once that's set up, I was thinking, and this is what I'm offering, is anybody here, since we all kind of know each other face to face, I'm offering that if people are interested, I would go ahead and set up logins for anybody who emailed me asking for one, with the idea that we could all contribute towards putting together information, links to things. We could have links to some of David's videos and things like that that say, this is how you do things, and start to put together a community resource of links, tutorials, recipes, things like that. But if no one has any interest, that's fine. I won't do it. But I'm I'm soliciting it.
A structured way.
I think there was a Slashdot article in the last few days. I didn't read it, but the headline was something like, "Please stop shutting down forums and moving to Discord."
Yeah. And frankly, you know, I've written to people how to do something like 4 times now, and I'd like to just point, you know, over here, there's a place to go.
Oh yeah, and a good one. You got Kelly's interested, Marie.
Yeah.
Okay, well, put it this way. I'll go ahead and set this wiki up. I mean, I have this New Zealand personal robotics wiki, which I could just use that one, and except that one is actually my wiki, and I'm paying for it. And this one is a temporary wiki with which we're going to prohibit images on. And if there's enough interest and it gets moving, then we'll solicit donations. You know, it only takes like about $100 a year or whatever to have 30 gigabytes in a reasonable running system. And what I would do is just move the whole thing over onto a paid system that was paid for by volunteers. And then I can just I don't have to pay for that after that. So the idea is to kind of see if we get interest, and if we get the ball rolling and there's some momentum, we would then move it over to a paid wiki under its own domain and stuff like that. So
personally, I think it's really impressive how you've got the activity that you do in the Discord, and you know, there's always going to be bad apples that take things in a crazy way, but I just know that personally, I'm already torn so many different ways. I can't keep up with the ones I'm already committed to.
Yeah, well, and frankly, it's the same for me. I've got plenty going on, and this is, you know, just adds to that. But to some degree, the enthusiastic people who have time could go ahead and post stuff there, and we'd each have our own personal page, and you can have a project page for each of your robots. And if you want to write a recipe for how to solder things, you know, that kind of thing. Because there isn't actually this kind of thing online anywhere, as far as I know. It's kind of scattered all over the place, but it's not really related to like building what we're calling personal robotics, you know, small robots for hobbyists.
It's all over the place.
There's FTC stuff, and there's competition stuff, and there's university level stuff, but it's not kind of what we do. So,
but it is sort of the, I think this is the point Kareem was making. It. Don't let me make your point for you, but the location of that information is called the internet.
It's irrelevant these days. You can find it, and it's the old search versus browse thing. And browse is becoming more and more irrelevant all the time, right? And it's necessarily going to be that way. You just look at the sort of the curves. I mean, what you're talking about is an editing process. You're not actually talking about a technology. You're talking
we're talking about curating.
You're talking about curating stuff with an explicit agenda, like a magazine editor or something like that, right? Well, there's a reason magazines have all died. It's because you don't need that anymore. There is still a call for high quality. I would argue that editing is always an important thing, but there's so many
I have to interrupt. I have to go downstairs because my basement is going to start flooding in a minute. So I've got to go down there and get a camera. I can't believe this is happening. I'm waiting for the phone call this whole time. I've been waiting for. Oh, it's going. Oh no, my partner's down there. I have a Raspberry Pi on the basement camera.
You know, this reminds me of when I was still working at Siemens PLM. One of the things I noticed is that
I gotta go.
Some of the engineers, that younger engineers that I mentored, have a problem organizing things, and I don't know if that's the trend nowadays among the younger crowd. Is they, I would basically tell an engineer, okay, here's a link to something, all right. Here's how to do something, save this link. Well, he would save all the links at the top level of his browser. So later on, he would come back and ask me, where's that? Well, how did you find, you know, where's that instruction on how to do this? I said, I gave you the link, but he can't find it because everything's at the top level and he has to scroll through the, you know, unorganized, and he would have to scroll through the entire list of links to find it again. I mean, that was one engineer. The other engineer, and I'm not sure this is indicative of the trend, but apparently he was just out of school, and his method of remembering things was to write everything down in a notebook. But see, it was the same way. It's basically just write down on pages serially, page after page after page. And he would come back to me a week after I told him something and ask me how to do something. Well, you wrote it down, don't you remember where to find it? So I'm seeing a kind of a trend where some engineers have no organization skills and their work suffers as a result of it.
Yeah, but it's a multi-generational thing, I would say. You know, I'm exposed to a lot of young people all the time, and the problem is information is ephemeral. The best quality information is going to change from 1 week to the next month and you're guaranteed to, if you have something archived in one small location, it's going to be dated, especially in a field that's moving as fast as robotics, right?
Even how you organize it, right? How you think about things evolves and changes. So
exactly,
that's where trying to curate it and organize it is a perpetual. But then, to my way of thinking, you get sites like Instructables or Hackaday, and they're good content creation sites, and you can search them. They still come in kind of randomly, but they're not necessarily organized like a book or
Well,
a
you know,
Well, and
structured
if
format.
if you think about it, the purpose of librarianship, and I actually have training in that, is to actually try to help people find things. And yes, there's certainly lots of things that are changing very rapidly, but like if I want to make a cable, or if I want to tell someone how to solder, or I want to point someone at resources, and I also allow people to update links and things like that, it's not that hard to actually put together resources for people. I mean, we're not talking about creating some massive Wikipedia thing. We're just talking a wiki full of some pages of people putting, their own robot projects and things like that. And it's, I don't know, I think we're making this into much bigger than it might simply be. It's just a resource for a community.
I'm not telling
There
you not
is-
to do it. I'm not.
Yeah.
I'm not saying that at all.
My
There's-
opinion is that all resources are valuable and there can't be too many of them.
There's some information science people in the building where I work, and one of them has a picture on her door of a library card catalog, one of those gorgeous oak things with thousands of drawers that's maybe 50 feet long with cross indexing and all that stuff. And underneath it, he wrote ancient Googling.
Yeah. Yeah.
You know,
I know, that's my background. I know that stuff. Yeah.
to Kumar's point about information gets out of date and all those sorts of things, I tend to, when I'm coding on a daily basis, that's kind of what I do, and I know some other people here do as well. I am very careful with my comments that I leave in the code. Anything other than I'm trying to do this or I'm trying to do that, if there's any really specific details, invariably, as soon as I write that line of code, check it in, the next day that comment is probably invalid.
But Harold, what you're arguing for is never writing anything down.
No, well, not necessarily at all. It just let's just decide where. For instance, your topic of how to solder. That's not going to change anytime soon. We may get some more stuff added to it. There's some big ubiquitous stuff like 1 + 1 is 2. That I know we all know that, but that sort of thing stuff. There's certain things that aren't going to change, haven't changed in hundreds of years, and not going to change going forward that may be useful to people in certain situations. And I think that's maybe the criteria.
Well, and there's the sort of stuff that never changes and stuff that changes daily. But we're talking about the midpoint, like how to write a PID controller, or how to have pointers to PID controllers, or I2C buses, or things like that. There's lots of information that people can find valuable.
Did any of y'all see the?
You just Google. I mean, I put on the list the other day an absolutely gorgeous explanation of spy bus. I mean, it was, somebody did it out there. All you have to do is Google it, and
yeah, and that's the purpose of curating, is to try to find those good resources. So, Doug, you acted in the purpose of curating for the rest of us a resource that you found.
Yeah, but what I'm saying is, when I want to learn something about, like, let's take something a little different, like welding. Okay, we probably not very many welders in this group. No, I'm not a welder. I'd like to weld, but so I have a welder. I've stuck metal together, but I won't say I'm a welder. But the fun thing about it is that when I go out and look, I just use the whole web to figure out what I'm trying to do. Like if they say, they're always telling me that I've got the wrong stuff and everything. So now, then I have to figure out. I'll find somebody who's got the same type of welder and figure out what he can do. I mean, it's just I thought about this because DPRG on our website does have a project and a tutorial section, and occasionally, very occasionally, something gets written down in there. I won't say it's the end all of everything, but I don't think anybody ever looks at it. It could be because the content's not as good as what's out there on other sites. And so that's what I'm saying is I don't think that any wiki that you can put together with a small number of people is going to be as good as what some person just using Google and finding out.
I think, but Doug, you've sort of made the argument for the wiki in the sense that you, as a senior member of the DPRG, one of the more experienced robot groups in the country, was able to find a resource that someone who's, let's say, a brand new builder who has no experience and has no idea what's important on a robot, doesn't know the difference between closed and open loop control, all those issues, they don't know that. They're searching through the entirety of the internet, and that's actually not helpful. It's everything's there, but finding what you need isn't helpful. There's no organization to it.
I'd like to point out something that college professors like to tell me when I was taking college. When I was doing my bibliography of things for my paper, if I used an internet source, they did not value that very much because lots of people talk on the internet, many of whom don't know what they're talking about. And if you've got a curated source, then that has some level of expertise. So I think there's value in both of the types of things.
So I would argue that within 3 minutes of reading some article, you can tell too shallow, wrong. I mean,
but Doug,
it doesn't take very long to. Well, if it's not useful for you, then you're looking at the wrong source.
There's lots of ways to go down a rabbit hole and not know you've gone down a rabbit hole until you've spent money and wasted time. And Doug, you're a perfect example of someone who knows that that's a rabbit hole, but there's lots of people who don't.
Well, I don't know. So I wouldn't say go that
So you're talking about a primer for the introductory language to robotics, so that you just know where to start.
Yeah, it's like having a page on open loop versus closed loop, and having a page on Pid Controllers, and having a page on how to solder and things like that.
There's something like that for the FTC community. It's called Game Manual Zero, and it has a lot of the stuff that you're already talking about.
Is that publicly available?
Yeah, anybody can go there.
Well, how would I find it?
It sounds to me like the argument comes down to this group can generate as a community information organized in such a way that's better than what you can find anywhere else. The argument seems to be being made, well, I can find that somewhere else. Can you?
Pretty much.
Well, in a lot of my projects, I always have a README file in my source code. And my README file typically has a reference area there. It has a dozen links because I have to find a little piece of information here and a little piece here. There's a lot of crap out there, especially on Slashdot. Anybody's allowed to post on public media sites, and often they're students, and they may have 2 things right and 1 thing wrong. And so you kind of need to filter it and edit it, and then put what's relevant, condense it into your own notes and everything. And if you can share it with somebody else, it really saves somebody else a lot of time, if you can.
I'm just basically asking the question. Do you think you can generate something that's unique?
Kelly, I would say that we do actually. So if you look at the club, just look at our monthly presentations, right? We have a lot of really valuable really unique monthly presentations. Most of them are from within the club. Some of them come from externally. But I mean, I can tell you as someone who's tried to recruit those for the last year and a half, almost 2 years, it takes a lot of work to pull any given one of those together, and it's not the easiest thing to find people willing to do that. So I'm getting the sensation that everybody loves to be able to find, however they do it, whether it's through a well-curated, well-structured site, at least structured in the way that the person wants to find information at the level they want to find it. I think we all love to find those kind of resources. And if we can't, then we Google it around until we do find one that suits our needs. But at the end of the day, how many of us are in a mode where we're going to sit down and output that kind of content after we scour and don't find it and come up with it to the level that we feel it's unique. So,
and we already have our favorite places to publish that information. Right.
That's,
So it's
yeah.
more, it's, you know, partly it's a matter of just deciding to put it all in one other place, or we already have whatever our outlets are, we've already got those established, and that's probably where we're going to publish.
Also,
Well, I
that
think one of the newer concepts actually is not trying to build content intently and everything. It's actually doing what you love to do, and then when you find a good formula for it, you share it and everything. And the content comes after you've developed the recipe and everything. It's like my website. We've got a group of 3D printer guys, and we share tips and things. And we find videos like how to solder and how to cut sheet metal and things, and we share it on our Facebook channel. And it's very interactive and everything, you know. And so we can post images from home, or even post YouTube videos, you know, and things. And so it's much more interactive and everything with other people, you know, all over the world and everything. And it's not putting something on an obscure bulletin board that's all text oriented, you know, like the 80s, you know, when you had to dial in on a phone bulletin board and everything. But like something like a Facebook is a good one for sharing, because you get instant feedback. People can just click, oh, I like that, you know, or where'd you find that, you know, and if there's a lot of interest, then you can expand on it and everything. And
So that's not unique to any one site.
Kelly, I think the point that was being made, maybe I misunderstood this, but really for that to work, it requires maintaining it all the time. I do the same thing you described. On my projects, I have a README, and I put in all the links and everything, you know, links to manuals and to where I bought this. And but what I find often is that when I go back to read those links are now dead. And it makes me think, oh, I should have downloaded that manual and included it in a doc directory and not just included the link. So to have anything like that, you know, the link rot happens real fast. And to really make it valuable, it has to be maintained and updated all the time. I spend a lot of time doing that at work. One of my failings at work, and not mine alone, is there's so much intellectual, what's the right word? Institutional knowledge that's not written down anywhere, because a lot of us have been there for a long time. And to even know what things should be documented is not always clear. Did anybody else attend the SRS meeting this weekend?
Yeah.
Okay, well, what this guy had, and this is maybe is a good case in point. There's this project. He's building a quad dog walker, and it looks a lot like the one from
Boston Dynamics.
Boston Dynamics, thank you. And the interesting part for me was that he went through a number of iterations. So his first design he was so excited about. He got the whole thing assembled and built and everything, and it just hardly worked at all. And so, I mean, he was like on iteration 4 or 5 by the time he showed us what he was working on. The other thing that struck me, and Carl, I saw you there, you might, professional robot builders have an advantage over us amateurs. And that advantage is money. I mean, this guy had $10,000 worth of CNC machined aluminum parts and so forth. And it's just something that, you know, even if he described in detail how he did it, it's not going to be that helpful to me. What he ended up with was pretty cool. That's it right there.
Yeah. And to my way of reading that, David, he basically showed his journey of building this company.
Yes.
I don't know if that's flashing for you, but it's
flashing.
Yeah, it just stopped.
That was weird. Okay. But yeah, he showed, and it was an 8 or 10 year history of getting to this thing, which, I mean, to the point that he built his own brushless motors, or I guess he kit bashed them by, it seems like he took common ones off the shelf, used an arbor press in his little room to take them apart, and then put them in his own mechanics in a certain way.
He put what's that kind of gear reduction called? Planetary. He put planetary gears inside the motors, inside the rotors. And he said that's actually mostly what he's sold, people making arms and so forth.
Yeah. Yeah, I was really impressed by. He's got
Okay,
you know,
okay, folks.
design,
Great. I'm out of here. You guys have
ham,
a great week.
Ray, you were
Take care, Harold.
Ray, you were there this weekend.
Yeah, actually, the I was coming home. You know, the meeting had already started, and I tried to get in on my phone, and for some reason it wasn't working. Got home and logged on, and I couldn't figure it out. There was this horrible echo. I was creating the echo by having two logons, and one of the, I think the whoever the moderator was said, you know, please log off. And I did, and it cut the echo out. So I was like, oh yeah, that was me. You know? Sorry about that.
Well, they also they had some crash.
Yeah.
Just about maybe 15 minutes into the guy's talk.
Right.
I thought they had just thrown out all the Dallas people.
Oh no. Yeah, I noticed that in the chat. There was like several people said, well, I guess there were emails. I've been kicked out. You know.
Yeah, Zoom did a forced update right in the middle, just as the guy was starting his presentation. Zoom did a forced update, and it crashed the entire meeting room.
Wow, is that what
it was remarkable.
Yep.
Did they record it?
Yes.
Yeah, so there's a part 1 and a part 2, I believe.
Yeah. So that's one of those things. It's like, boy, that echo is horrible. I wonder what's causing that. It's like, oh, I'm causing it.
John, that thing you thought was a bear is actually this large cat, which I never let out here into the shop, but I let him out here this evening. And he remembered from like the last time he was out here that there is heat shrink tubing, which is great fun to chew on and play with, that can be dug loose if you know the right spot. And he went straight to that spot. So.
Oh boy. You better watch out. I don't know if that stuff is toxic or not.
I keep finding little chewed up pieces of it scattered around the house.
I made the mistake of, you know, you I don't know if you can see this, you know, for soldering the wick that you put in your solder iron. This is basically copper sponge.
Yep.
I made the mistake of leaving one of those out, and one of my cats found it, and there's little bits all over the carpet everywhere.